You might think of leaving our Milky Way like moving to a new, brighter city. A grand adventure, a fresh start on a new cosmic shore among a trillion new stars. It's an idea woven into our dreams, the final frontier for a species of explorers. We see the swirling arms of Andromeda in our telescopes and just imagine being there, walking on alien worlds under alien suns. But what if it's not like that at all? What if leaving our galaxy is more like trying to escape a gravitational prison the size of a continent? A prison whose walls are made of spacetime itself. What if the journey isn't just long, but fundamentally, physically, impossible? Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. So, let's take our time. We're going to slowly uncover the layers of this impossibility. We'll build the case, piece by piece, that explains why the invisible structure of our universe might make leaving the Milky Way a dream we can never realize. This isn't a story about our technology failing us, but a quiet truth written into the very geometry of gravity and the brutal scale of everything. The first wall. The true scale of our prison. When you think about leaving the galaxy, what do you picture? Probably the bright, flat disk of stars we see in artists' drawings, a sort of cosmic frisbee floating in space. It looks vast, sure, but it seems to have a clear edge. Fly past that last star, and you're out. You've crossed the border into the great intergalactic dark. This first picture is maybe the most profound misunderstanding. The galaxy is not just what you see. The glowing part, the part with our sun and the hundreds of billions of other stars, is just the brightly lit courtyard of a much larger, and almost entirely invisible, structure. The part we can see, this beautiful spiral, is enormous beyond our comprehension. Current estimates put it somewhere between 100,000 and 180,000 light years across. A light year is a journey of nearly 6 trillion miles. To give you some perspective, the Voyager 1 spacecraft, the fastest and most distant thing humanity has ever made, has been traveling for nearly 50 years and has covered just over 22 light hours. If Voyager were to travel across the galaxy's visible disk, the trip would take it about 1.7 billion years. Our solar system is about 27,000 light years from the galactic center, tucked away in a small spiral arm called the Orion Arm. From here, we orbit the galactic core, a dense bulge of old stars, gas, and dust. At its very heart sits a supermassive black hole, Sagittarius A*, an object with the mass of 4 million suns. This visible part, the disk, the bulge, the black hole, is already an impossibly large system. But it's not the true boundary. It's just the downtown core. Surrounding this entire visible structure is something far, far larger, the stellar halo. Picture a vast, ghostly sphere of ancient stars and huge globular clusters, all orbiting the main disk like lonely satellites. This halo is incredibly sparse, like a faint, forgotten mist. For a long time, we thought this halo extended out to maybe 300,000 light years. But we keep finding our galaxy's stars further and further out. Astronomers have now found stars belonging to the Milky Way over 1 million light years away, nearly halfway to the Andromeda galaxy. This means the stellar halo, this sprawling suburb of our galactic city, is at least 2 million light years in diameter. The galaxy you see is just a small, bright piece inside a stellar structure 20 times wider. We aren't in a city, we're in a sprawling, continent-sized megalopolis, and we're parked in a quiet neighborhood. But even that isn't the whole story. The stars, the gas, the dust, everything that shines makes up only about 10% of the galaxy's total mass. The other 90% is something we call dark matter. It's invisible. It doesn't emit light, reflect light, or interact with us in any way we can directly see. We only know it's there because of its immense gravitational pull. It's the invisible glue holding the whole galaxy together, stopping the outer stars from flying off into the void. This dark matter forms its own colossal halo, a cloud that engulfs everything we've talked about. The latest thinking suggests this dark matter halo, the true gravitational boundary of our galaxy, stretches out nearly 2 million light-years in diameter. The total mass of this entire system, visible and dark, is around 1.5 trillion times the mass of our Sun. So, what does it mean to leave the galaxy? It doesn't mean flying past the edge of the disk. It means breaking free from the gravitational grip of this entire 1.5 trillion solar mass system. To escape, you have to overcome the gravity of not just the stars you see, but the crushing, invisible weight of a dark matter halo that is 10 times more massive and 20 times wider. This is the first wall, scale. The prison is so much bigger than it looks. We're not trying to walk out of a room. We're trying to climb out of a gravitational well that is 2 million light-years wide. And to do that, you need to be moving incomprehensibly fast. The second wall, the universal speed limit. To escape a gravitational field, you need to hit escape velocity. Here on Earth, a rocket has to reach about 11.2 kilometers per second, or 25,000 miles per hour, to break free. To escape the Sun's gravity from our orbit requires about 42 kilometers per second. These are huge speeds, but we can do it. But to escape the Milky Way from our position? That's a whole different game. When you factor in the colossal mass of the dark matter halo, astronomers figure a spacecraft would need to hit a speed of around 550 kilometers per second. That's nearly 1.23 million miles per hour. That kind of speed is far beyond what our current propulsion can do. But let's just imagine for a second that a future civilization could build an engine that powerful. Even if they could, a much bigger, more fundamental barrier stands in the way: the speed of light. Einstein's theory of special relativity is one of the most rigorously tested ideas in all of science, and it sets a universal speed limit. Nothing with mass can travel at the speed of light, and nothing can go faster. This isn't a technological hurdle, like breaking the sound barrier. It's a basic rule of the universe. The reason why is one of the strangest ideas in physics. As you accelerate an object with mass closer and closer to the speed of light, it actually gets heavier. The energy you're pouring into it to make it go faster gets converted into mass, according to E equals mc squared. As you get closer to the speed of light, this effect becomes exponential. The object gets heavier and heavier, so you need more and more energy to speed it up just a little bit more. To actually reach the speed of light, an object's mass would become infinite. And to accelerate an infinite mass, you'd need an infinite amount of energy. There just isn't enough energy in the universe to get even a single atom to light speed, let alone a starship. So, the speed of light, about 300,000 kilometers per second, is the absolute cosmic speed limit. Our galactic escape velocity of 550 kilometers per second is only about 0.18% of that. A journey at this slow speed to the edge of the stellar halo, a million light-years away, would take over 500 million years. The nearest major galaxy, Andromeda, is 2.5 million light-years away. That trip would take well over 1 billion years. The journey is just too long for any ship or crew we can imagine. This is where science fiction usually brings up traveling near the speed of light to take advantage of time dilation. That's the phenomenon where time slows down for a moving person compared to someone standing still. If you could travel at, say, 99.999% of the speed of light, a journey of thousands of light years might feel like only a few years to you. You could cross the galaxy in a human lifetime. It sounds like a clever loophole, but it just brings us crashing into our next wall. The problem isn't just the speed limit, it's the price of admission to the high-speed lane. The energy required is practically infinite. And even if it weren't, the universe has placed other, more violent obstacles in your path. Interstellar space isn't perfectly empty. It's filled with sparse hydrogen atoms and dust. At normal speeds, that's not a big deal. But at relativistic speeds, it becomes a shooting gallery. As you approach the speed of light, those tiny bits of dust and gas would hit your ship like a beam from a particle accelerator. Each tiny atom would impact with enormous energy, creating a lethal spray of radiation that would kill any crew and fry the ship's electronics. Shielding against this is a monumental challenge. Some studies suggest that to avoid being cooked by the journey itself, a practical top speed for any ship might be around half the speed of light. At that speed, time dilation helps, but not enough. A trip to the galactic center, 27,000 light-years away, would still take 54,000 years. The speed of light isn't a goal to reach. It's a wall. It defines how fast we can go, which in turn defines how far we can ever hope to get. And the energy needed to even get close to this wall is our next great barrier. The third wall, the tyranny of the rocket equation. For any journey, you have to bring your own fuel. This simple fact leads to one of the most brutal rules in space travel, the Tsiolkovsky rocket equation. First figured out in 1903, this equation reveals a harsh truth: to gain more speed, you need more fuel. But that fuel has mass. And to accelerate that extra mass, you need even more fuel. It's a vicious cycle. For rockets leaving Earth, this is why over 90% of their weight is just propellant. Now, let's apply this to an intergalactic trip. We're not talking about a few kilometers per second anymore. We're talking about hundreds just to escape the galaxy, and near light speeds to make the journey survivable. The energy requirements aren't just big, they're astronomical. Chemical rockets, like the ones that took us to the moon, are completely hopeless for this. They're too inefficient. To reach even a tiny fraction of light speed, a chemical rocket would need more fuel than there is mass in the known universe. So, we have to think about more advanced, theoretical ideas. The most powerful fuel source we know of is matter-antimatter annihilation. When matter meets antimatter, 100% of their mass is converted into pure energy. It is the perfect fuel. Let's imagine a future where we've somehow mastered making and storing antimatter. How much would we need? Calculations show that to get a ship to a significant fraction of light speed and then slow it down at the other end, the amount of fuel required would still be many, many times the mass of the ship itself. For example, one proposal to send a tiny, unmanned probe to Alpha Centauri using powerful lasers, a concept called beamed propulsion, would require roughly 10 to the power of 19 joules of energy. That's nearly the total energy our entire civilization uses in a year, just for a one-way, unmanned trip to our closest neighbor. For a crewed ship going to another galaxy, the numbers just become meaningless. We'd be talking about energy outputs that dwarf the sun. This is the tyranny of the rocket equation. Carrying your fuel makes you heavy, and being heavy costs an insurmountable amount of power. So maybe you don't carry your fuel. What about a light sail? A giant, thin mirror pushed by photons from a powerful laser back in our solar system. This gets around the rocket equation because the ship isn't carrying a heavy engine or fuel. It's a great idea for trips between stars, but for a journey between asterisk galaxies, it hits its own impossible problems. First, the laser would have to be unbelievably powerful. Second, it would have to stay perfectly focused on a sail millions of miles wide from light years away. As the ship gets farther out, the beam just spreads out and gets weaker. But the biggest problem is stopping. Once you arrive, a million light-years from home, how do you slow down? There's no laser waiting there to push you the other way. You'd either need to have brought a second propulsion system with you, which puts you right back under the thumb of the rocket equation, or you just fly by at incredible speed. The light sail is great for a one-way flyby, but not for stopping. The energy problem reveals a deep truth. The universe has placed a fundamental tax on motion. Every bit of velocity has a cost, and that cost rises exponentially as you approach the ultimate speed limit. To pay for a trip to another galaxy would require a civilization that can harness the energy of entire stars, maybe even entire galaxies. We are not even a Type 1 civilization on the Kardashev scale, which can harness all the energy of its home planet. The energy required is so vast that any conventional propulsion, no matter how advanced, seems like a dead end. But even if we could somehow find a loophole in the laws of energy, the universe has one more, final barrier, and it's getting stronger every second. The expanding prison. The unseen current of dark energy. So far, we've been talking about this journey as if we're crossing a static ocean. But what if the ocean itself was expanding? What if the very space between us and our destination was stretching, carrying the distant shores away from us like a relentless cosmic current? This isn't a metaphor. This is our reality. In 1929, the astronomer Edwin Hubble discovered that distant galaxies are all moving away from us. And the farther away a galaxy is, the faster it's going. This was the first evidence that the universe is expanding. The key thing to understand is what's expanding. The galaxies aren't just flying through space like shrapnel. The fabric of spacetime itself is expanding, carrying the galaxies along for the ride. Think of dots on the surface of a balloon. As you inflate it, every dot moves away from every other dot, but none of them are actually walking on the rubber. For decades, astronomers thought the gravity from all the matter in the universe would be slowing this expansion down. But in 1998, two teams of scientists studying distant exploding stars made a shocking discovery. They found that the expansion of the universe is not slowing down. It's speeding up. Something is actively pushing space apart, overpowering gravity on the largest scales. We have no idea what it is. It's the single biggest mystery in physics. We call it dark energy. It seems to be a property of empty space itself. The more space there is, the more dark energy there is, which pushes space to expand even faster. Today, we think dark energy makes up about 68% of everything in the universe. So what does this mean for our dream of intergalactic travel? It means our prison walls aren't just there, they are actively moving away from us. The galaxies in our immediate neighborhood, called the local group, are bound together by gravity. This little island, which includes the Milky Way and Andromeda, has overcome the cosmic expansion. Andromeda is actually on a collision course with us, set to merge in about 4-5 billion years. But beyond our local group, it's a different story. Every other galaxy cluster in the universe is being carried away from us by the expansion. And since that expansion is accelerating, they're moving away faster and faster over time. This leads to a chilling conclusion. There's a cosmic event horizon, a distance beyond which galaxies are receding from us faster than the speed of light.
Because space itself can expand faster than light, these galaxies are being carried away at impossible speeds. Light from them will never reach us. They are, and forever will be, cut off from us. No signal we send, no ship we launch, can ever cross the expanding gulf of space-time that separates us. The observable universe is about 93 billion light-years across. But the vast majority of the galaxies inside it are already forever unreachable. Only a tiny fraction are even theoretically within our reach. And even for these closer galaxies, the expansion acts like a constant headwind. A ship would have to fight against stretching space-time the entire way. The farther it travels, the stronger that headwind gets. This adds yet another astronomical energy cost to the journey. And it's only getting worse. As time goes on, more and more galaxies will cross that event horizon, winking out of our reach forever. In the far, far future, our local group might be the only thing left in our sky. All other galaxies will have disappeared beyond the horizon, leaving us in a vast, empty void. This is the final wall. We aren't just trapped by the gravity of our own galaxy. We are confined by the very nature of spacetime itself. The universe is actively working to isolate us. Our prison is expanding, debunking the sci-fi escape routes. So if conventional physics won't get us there, what about the unconventional? Science fiction has given us plenty of imaginative escape routes, most famously the warp drive and the wormhole. Could they offer a way out? Let's start with the warp drive. The idea is to create a bubble of normal spacetime around a ship, then contract spacetime in front of the bubble and expand it behind. The ship just sits inside the bubble as it gets carried along on this spacetime wave, potentially faster than light. It sounds like the perfect solution, but it comes with some fatal flaws. To make it work, you'd need a supply of exotic matter with negative mass or negative energy. We've never seen anything like this in nature. The amount of this hypothetical matter you'd need is staggering, maybe as much as a large planet or a star. So you run into an impossible roadblock. You need a substance that might not even exist. Then there are the other problems. The bubble might be incredibly unstable. It might be impossible to steer from the inside. And some theories suggest that the moment you tried to turn it on, it would destroy itself. For now, the warp drive remains pure speculation. What about our other great hope, the wormhole? A hypothetical tunnel through space-time, creating a shortcut across the cosmos. You wouldn't travel faster than light, you'd just take a shorter path. Like the warp drive, wormholes are technically allowed by Einstein's equations. But those same equations suggest they'd be useless for travel. A natural wormhole would collapse so fast that not even light could make it through. To hold one open, you'd again need a huge amount of that same exotic matter with negative energy. And even if you could find it, where do you get a wormhole? You'd have to find one that formed naturally, which we have no evidence for, or create one yourself. Making one would require bending space-time so extremely you'd be creating and manipulating black holes with godlike precision. It's a level of engineering so far beyond us it borders on magic. These sci-fi solutions aren't really solutions. They're just restating the problem in a different way. To break the rules of travel, you need to break the rules of physics as we know them. They are fascinating ideas, but they don't represent a real escape plan. The walls of our prison remain standing. We've journeyed through the immense scale of our galaxy, the unbreakable speed limit, the impossible cost of energy, and the relentless expansion of space. Each barrier, on its own, seems insurmountable. Together, they form a near-perfect prison. It can be a sobering, even disheartening, thought. But I want to ask you, how does this make you feel? Does it feel like a cosmic injustice, a frustrating limit on our potential? Or does it change your perspective on our place in the universe? Let me know your thoughts in the comments. What is your wildest escape plan? The palace of our prison. We have spent this time together slowly building the walls of our cosmic prison. We are bound by the invisible gravity of our home. We are limited by a universal speed limit. We are shackled by an energy cost that is functionally infinite. And we are adrift in a universe that is actively pushing our destinations away from us. It's easy to see this as a grim story of confinement. But maybe we've been using the wrong word all along. Perhaps the Milky Way is not a prison. Perhaps it's a palace. We dream of other galaxies and the trillion stars in Andromeda because we are explorers. But we often forget the staggering scale of the home we already have. Our galaxy has somewhere between 100 and 400 billion stars. Recent estimates suggest there could be as many as 6 billion Earth-like planets orbiting Sun-like stars in the Milky Way alone. 6 billion potential worlds. We have barely begun to explore our own solar system. The vast majority of our own celestial backyard is a mystery. Beyond it lie billions upon billions of star systems, each with its own potential for wonders we can't even imagine. There are neutron stars, black holes, vibrant nebulae where new stars are being born, and ancient clusters that hold the secrets of the galaxy's birth. Our galaxy isn't some small town we're desperate to leave. It's an unexplored continent, with enough mystery and beauty to occupy 1,000 civilizations for 1,000,000 years. The very forces that keep us here, the immense gravity, the stable structure, also make this a safe harbor, protecting us from the chaos of intergalactic space. Realizing that we may never leave our galaxy isn't about abandoning the dream of exploration. It's about refocusing it. It's about understanding that the greatest adventure isn't necessarily out there, but in here. It is to turn our gaze inward, to the 100,000 light years of home, and to truly appreciate the boundless complexity and wonder contained within our magnificent, inescapable palace of stars. The journey to another galaxy may be impossible, but the journey to understand our own has just begun. Part 2. How big the Milky Way really is. At first, the idea sounds simple. If one day humanity ever wants to leave the Milky Way, then all we would need to do is keep traveling in one direction long enough. Keep going, past the nearest stars, then the distant ones, then the outer edge, and eventually our galaxy would fall behind us like a city disappearing in a rearview mirror. But the moment you slow down and ask a quieter question, the whole idea begins to change. How big is the Milky Way, really? Not in the way we casually say something is big. Not in the way a mountain is big, or an ocean is big, or even the way Earth feels big when you are looking out the window of an airplane. The Milky Way is big in a way that almost refuses to fit inside the human mind. It is so large that most of our instincts about travel, distance, and even location stop being useful. And that may be the first truly unsettling thing about trying to go beyond our galaxy. Before we ever face the darkness between galaxies, before we ever worry about fuel, time, or survival, we are already forced to confront a simpler problem. Home itself is far larger than we emotionally understand. If these slow journeys through science help you relax a little, you can always leave a like, subscribe, or share a thought in the comments later on. I always like hearing where people are listening from, especially when the subject is something as quiet and enormous as this. The strange thing is that most of us do carry a picture of the Milky Way in our minds. It usually looks like a graceful spiral, bright in the middle, with curved arms reaching outward into the dark. It is beautiful, elegant, and strangely familiar. We have seen versions of it in books, documentaries, posters, and animations for years. A galaxy, in that simplified picture, almost looks manageable. Huge, of course, but still something you can imagine crossing if you had enough patience. The problem is that this picture is too neat. It gives the galaxy a shape, but not a feeling. It gives the Milky Way an outline, but not a sense of what it would actually mean to move through it. A spiral seen from far away looks like a single object. But if you were living inside it, which we are, it is not one thing. It is a vast region of stars, dust, gas, radiation, gravity, and empty distances so wide that a single step of comparison can leave the mind behind. A useful place to begin is not with the whole galaxy, but with the nearest star beyond our Sun. That star is Proxima Centauri, and it is about 4.24 light-years away. That number is already easy to say and almost impossible to feel. A light-year is the distance light travels in 1 year, and light moves at around 300,000 kilometers every second. In just 1 second, it can circle Earth more than 7 times. And even moving that fast, it would still take over 4 years to reach the nearest star. That means the nearest stellar neighbor is not minutes away, not days away, not even months away. It is more than 4 years away at the fastest speed the universe allows. And that is only the nearest star. Voyager 1, the most distant human-made object ever launched, has been traveling since 1977. It has left the planets behind. It has left the main zone of the solar system behind. It is out in the dark now, moving farther every day, one of humanity's greatest engineering achievements. And yet if Voyager 1 were aimed at the nearest star, it would not arrive in 4 years. It would not arrive in 40 years. It would need tens of thousands of years. So before we even leave our local neighborhood, the scale of interstellar travel is already stretching into time periods longer than civilizations. Now widen the view. Our sun is not near the center of the Milky Way. It lives out in the disk, in a quiet region about 26,000 to 27,000 light years from the galactic center. That means if you could somehow travel in a straight line toward the center at the speed of light, the journey would take roughly 26,000 years. Not because the center is unreachable in principle, but because that is simply how far away it is. 26,000 years. When people first hear that number, they often think of ancient history. But even that does not quite capture it. 26,000 years ago, human civilization as we know it did not exist. Agriculture had not begun. Cities had not risen. Written language had not been invented. Kingdoms, empires, modern religions, science, industry, electricity, computers, rockets, all of that still belonged to a future so distant that it would have seemed impossible. So when we say the center of our own galaxy is 26,000 light-years away, what we are really saying is that even light itself needs a stretch of time longer than the whole story of civilization just to get there from here. And the center is not the edge. The visible disk of the Milky Way is often estimated at roughly 100,000 light-years across, though the precise number depends on how you define the outer boundary. Some measurements push it larger. Some descriptions focus on the main luminous disk. But even if we stay with the familiar figure of around 100,000 light-years, the point is already clear enough. Light, moving at the fastest speed possible, would need around 100,000 years to cross it. Imagine that for a moment. If a beam of light began its journey across the Milky Way when early humans were still painting caves and shaping stone tools, it would only now be reaching the other side. That is not a poetic exaggeration. That is what the scale actually means. And light does not get tired. Light does not need food, sleep, shielding, maintenance, or hope. So whenever we imagine a spacecraft crossing the same distance, we are imagining something slower than light trying to cross a realm already so large that even light needs geological stretches of human time to make the trip. There is another detail that quietly deepens the picture. The sun is moving too. We often talk as though the solar system is parked in space, as though we are standing still while the stars form a backdrop around us. But the sun is orbiting the center of the Milky Way at a speed of roughly 220 kilometers per second. That is fast enough to circle Earth in a few minutes. And yet the galaxy is so large that one full orbit of the galactic center takes the sun around 225 to 250 million years. This means the last time the sun was in roughly this part of its galactic orbit, Earth was a different world. Dinosaurs had not yet appeared. Continents were arranged differently. Life was older, stranger, and far less familiar. 1 year on Earth feels substantial to us. A century feels historical. But the galaxy moves to a different rhythm altogether. 1 galactic year is long enough for entire branches of life to rise and vanish. There is something deeply calming about that, and also something humbling. It means our entire recorded history, from the first written words to the present day, occupies only the tiniest fraction of 1 galactic orbit. Human history is not even a blink on the Milky Way's clock. It is closer to the flicker of a thought. And yet even the disk is only part of the story. When people picture the Milky Way, They usually imagine the flat spiral plane, because that is where most of the bright stars and clouds of gas are concentrated. But the galaxy is not a thin drawing. It has thickness. The central bulge rises outward from the disk. Old stars surround it. Globular clusters orbit in a larger halo. And beyond the bright structure we can easily visualize lies something stranger and harder to picture, a much larger gravitational domain shaped by dark matter. You do not need to dive too deeply into dark matter to feel the consequence. The visible galaxy is not the whole galaxy. What shines is only part of what is there. The gravitational reach of the Milky Way extends far beyond the most beautiful photographs. In other words, the home we casually describe as one spiral galaxy is actually more like a layered kingdom with bright inner provinces and a much larger invisible borderland. That matters because when people imagine leaving the Milky Way, they often imagine crossing the bright edge. But the bright edge is not the same as being free of the galaxy's full influence. The visible stars may thin out, but the larger structure, and the gravity that comes with it, reaches much farther. It is a bit like living in a city at night. From a hill in the distance, the city seems to end where the lights stop. But anyone who has ever driven out of a large city knows that its true footprint continues past the skyline. There are suburbs, industrial edges, highways, power lines, freight routes, and invisible systems feeding the life of the center. The border is not where the lights fade. The border is farther out than the eye first tells you. The Milky Way is like that, but on a scale so extreme that even the analogy breaks. The disk itself is already filled with distances that challenge language. The Orion Arm, where our sun resides, is just a minor spiral arm structure. We are not in some privileged central location. We are not standing on a balcony at the heart of the galaxy. We are living in one neighborhood among many, circling a distant center we cannot see directly because dust clouds block much of the view. Our own galaxy is so large, and we are so deep inside it, that we cannot even photograph it from the outside. All the familiar artists' renderings are reconstructions, made by piecing together the structure from our position within the system. That detail alone is worth pausing on. Human beings have photographed Earth from space. We have photographed the Moon, Mars, Jupiter, Saturn, and galaxies billions of light years away. But we cannot take a family portrait of the Milky Way from the outside, because we are inside the family. We are trying to infer the shape of a forest while standing in one of its trees. And perhaps that is why the size of the Milky Way remains emotionally slippery. We can state its diameter. We can map its arms. We can calculate its mass. But emotionally, we still tend to imagine it as a single object in front of us rather than an all-encompassing environment around us. The difference matters. A single object can be crossed. An environment must be lived through. If you were traveling through the Milky Way, you would not be cruising over a neat spiral painted on black velvet. You would be moving through regions where stars are clustered more densely, where dust obscures sight, where radiation fields change, where the background itself slowly shifts over centuries and millennia. The galaxy is not merely a destination. It is a vast medium. And because it is a medium, travel through it begins to feel less like crossing a map and more like surviving an era. This is why ordinary travel metaphors fail us. A continent can be crossed in hours by plane. An ocean can be crossed in days by ship. Even the whole Earth can be circled quickly with modern technology. But the Milky Way refuses this kind of thinking. It is too large to be conquered by speed in any familiar sense. Once distances are measured in thousands and tens of thousands of light years, the problem is no longer only engineering. It becomes philosophical. It forces us to ask whether a trip that lasts longer than civilizations, languages, religions, nations, and perhaps even species continuity should still be called a trip at all. Because what exactly would arrival mean after 10,000 years? Or 50,000? Or 100,000? Who would leave? And who would arrive? Would they still belong to the same culture? The same biology? The same memory of why the journey even began? These questions start to emerge naturally once the scale becomes real. A galaxy is not just big enough to slow a spacecraft. It is big enough to dissolve the human assumptions that usually make travel meaningful. There is another quiet way to feel this scale. Look up on a dark night, away from the city, and you may see the Milky Way as a pale band across the sky. It can seem soft, almost delicate, like a cloud of powdered light. The emotional impression is often one of beauty and stillness. But that glowing band is not a surface. It is the combined light of vast numbers of stars spread across huge distances, seen edge-on through the disk of our own galaxy. What looks like a single band is actually depth layered upon depth, distances stacked behind distances, light from stars that may be hundreds or thousands of light years farther than others in the same line of sight. So even what appears calm and simple from Earth is already a visual compression of overwhelming scale. The human mind is built for local survival. It handles rooms, trees, roads, voices, weather, and the changing faces of people we know. It can learn bigger abstractions, but it does not feel them naturally. That is why science is so powerful and so strange. It lets us know things we cannot instinctively grasp. It teaches us to live with truths much larger than our senses were built to carry. And the Milky Way may be one of the best examples of that. We know, intellectually, that our galaxy contains perhaps 100 billion stars, perhaps more. We know that many of them likely host planets. We know the distances between those stars are often measured in light years. We know our own sun takes hundreds of millions of years to circle the center. We know the galaxy's larger gravitational reach extends beyond what we can easily see. But emotionally, many of us still feel as though the galaxy is a backdrop. It is not a backdrop. It is the entire stage on which our history has unfolded. Every story humanity has ever told, every war, every prayer, every song, every birth, every grave, every question we have asked about the universe, all of it has happened in one tiny corner of one spiral arm of one galaxy among many. And even that galaxy is so large that its true size still resists our intuition. That may sound discouraging at first, but there is another way to hear it. It means home is not small. It means the place we already inhabit is not some narrow launch pad we have outgrown. It is a vast and layered structure with more room for mystery than our species has yet begun to explore. Sometimes when people think about the future, they imagine meaning lies somewhere far beyond the Milky Way, as though another galaxy would somehow be more worthy of our wonder. But the scale of our own galaxy suggests the opposite. We have not exhausted home. We have barely introduced ourselves to it. There are stars in the Milky Way whose light will not reach us for tens of thousands of years after leaving them. There are ancient clusters still moving through the halo. There are stellar nurseries hidden in dust. There are dead stars, rogue planets, black holes, molecular clouds, and quiet systems circling in darkness. The Milky Way is not one place. It is 100 billion places and the enormous emptiness between them. And once you begin to feel that, the dream of going beyond our galaxy changes shape. It no longer feels like stepping over a border. It feels more like asking whether a creature born in one valley, who has not yet crossed its own mountain range, truly understands the land it already stands in. Maybe that is the quiet lesson of scale. Not simply that the Milky Way is too large for easy travel, but that size itself changes meaning. Beyond a certain point, distance becomes more than mileage. It becomes time, identity, fragility, patience, and perspective. It becomes something that can humble a species before that species has even left its own neighborhood. And that is why the Milky Way matters so much to this larger question. Because before we ask whether humanity could ever complete a journey beyond our galaxy, we have to sit honestly with the size of the place we would be leaving. We have to understand that the Milky Way is not a nearby shell around us. It is an immense realm. A structure so broad that even light moves through it like a patient traveler. Once that truth begins to settle in, the next thought arrives almost on its own. If home is this large, then what must the space beyond it be like? And if crossing our own galaxy already strains the imagination, then the darkness between galaxies may be something even quieter, colder, and more absolute than we usually dare to picture. Part 3. The empty distance between galaxies. By the time you begin to feel the size of the Milky Way, a strange thought starts to appear almost on its own. If our own galaxy is already this large, then what exactly lies beyond it? Not beyond Earth, not beyond the solar system, not even beyond the outer stars of our local region, but beyond the whole galaxy itself. Beyond the spiral arms, beyond the bright river of stars, beyond the invisible gravity that reaches farther than the eye can see. The answer sounds simple at first. Space. Just space. But that word is far too small for what it is trying to describe. Because the space between galaxies is not just more of the same. It is not like the distance between cities, or even the distance between stars. It is something quieter than that. Something emptier. Something so stretched out and thin that the mind has trouble finding anything familiar to hold on to. And that may be the first truly unsettling thing about the journey beyond our galaxy. It is not only that the distance is huge, it is that the distance is mostly made of almost nothing. That sounds harmless when said casually. Almost nothing. But in the deep universe, almost nothing can become one of the hardest things to cross. If you enjoy these slow journeys through science, you can always leave a like, subscribe, or tell me in the comments what part of the universe feels most mysterious to you. I always like seeing which questions linger in people's minds when the room gets quiet. When most people picture space travel, they still carry an old emotional image with them. A spaceship moving through a rich and detailed universe. Stars everywhere. Nebulae glowing in the distance. Planets drifting by. Strange horizons waiting ahead. The imagination tends to make the cosmos feel full, almost crowded with beauty. And in some regions, it is. Inside a galaxy, there are stars, clouds of gas, pockets of dust, dark objects, violent events, and subtle structures layered across enormous distances. Even there, most of space is still empty by human standards, but at least it is an emptiness with scenery. A star may be very far away, yet another one waits beyond it. There is a sense, however faint, that you are moving through a place. Intergalactic space feels different. It is not just empty in the ordinary sense. It is empty in a way that strips away the feeling of progression itself. To understand that, it helps to look at the nearest major galaxy to our own, the Andromeda Galaxy. It is the one people most often mention when they imagine leaving the Milky Way and reaching somewhere else. Andromeda is not some remote fantasy far beyond the edge of the observable universe. It is our large galactic neighbor. It is visible, faintly, from Earth's dark skies. It belongs to the same local cosmic neighborhood. And yet Andromeda is about 2.5 million light-years away. That number is so large that the mind usually lets it pass by without fully reacting. 2.5 million light-years. It sounds almost like a label rather than a reality. But the meaning is staggering. The light entering your eyes from Andromeda tonight began its journey long before modern humans existed. Long before cities, writing, agriculture, or recorded history. That light set out across intergalactic darkness while early human ancestors were living lives so distant from ours that even the shape of the human future was still hidden. So when we look at Andromeda, we are not looking across a very long road. We are looking across a gulf so wide that light itself needed millions of years to bridge it. And again, light does not sleep. Light does not age. Light does not need systems, repairs, hope, food, shielding, or memory. It simply travels. Any vessel carrying life would do worse. There is something almost cruelly simple about that. Because once you say the number out loud, you realize that the real problem is not just speed. It is what kind of emptiness that speed must endure. Inside a galaxy, even very large distances are still distances within a structure. There is gravity all around you from billions of stars. There are regions of denser gas. There are clusters, clouds, magnetic fields, radiation sources, stellar remnants, and the quiet architecture of a galactic disk. But between galaxies, those familiar features begin to thin away. You enter a realm where the universe feels less like a place and more like an absence. There is matter in intergalactic space, of course. Tiny amounts of gas, diffuse particles, radiation passing through, unseen dark matter shaping the broader gravitational landscape. But compared with the inside of a galaxy, it is incredibly sparse. So sparse that calling it empty, while not perfectly precise, is emotionally closer to the truth than calling it full. And that emptiness creates a strange kind of challenge. Because when people think of obstacles, they usually imagine something solid. A wall, a mountain, a storm, a hostile environment pressing against them. But emptiness is its own kind of obstacle. In some ways, a harder one. A place with almost nothing gives you almost nothing back. No easy resources. No convenient fuel stops. No natural shelter. No nearby worlds. No meaningful margin for error. If something goes wrong in deep intergalactic space, there may be no such thing as a nearby detour. It is the difference between being stranded on a remote island and being stranded in the middle of an ocean so large that every direction looks the same for longer than human history. At least an island is a place. Intergalactic space barely is. And perhaps that is why the dream of crossing it feels so different when you slow down. It begins not to resemble travel, but exile from structure itself. Imagine leaving the last outer stars of the Milky Way behind. At first, maybe there would still be a glow. The galaxy would remain a great disk of distant light, gradually shrinking behind you. Ahead, Andromeda might seem like a faint promise, still impossibly far away. For a while, the journey might still feel connected to two destinations, one behind and one ahead. But what about the middle? What about the long span where the home galaxy has faded into a remote brightness, and the destination galaxy still remains little more than a pale thought? What does a journey feel like when, for perhaps thousands, tens of thousands, or hundreds of thousands of years, the visual truth changes almost not at all? That question matters more than it first seems. Because human beings rely on change to feel movement. We know we are going somewhere because landmarks shift. The road bends. The weather changes. The coastline appears. The horizon moves. Progress has signs. Even on a ship at sea, the sky changes, the water changes, time changes, and arrival eventually gathers shape. But in the deep gulf between galaxies, progress may be almost invisible to anyone experiencing only a human lifetime. The stars behind you would still look like stars. The destination ahead might remain a distant blur for ages. The differences from year to year could be too subtle to comfort the human mind. And that introduces a deeper problem. The journey would not only be long, it might feel directionless, even if your instruments insisted otherwise. There is a kind of emotional starvation that can come from sameness. A quiet wearing down of meaning when every day resembles the last. Humans are not built only to survive physically. We also need pattern, novelty, orientation, and the feeling that effort is leading somewhere. Intergalactic travel threatens that in a particularly severe way, because the environment itself offers so little feedback. The universe would not be cheering you on. It would barely be acknowledging your passage. This is where the idea of emptiness becomes heavier than it sounds. An empty road is still a road. It has edges, texture, signs, memory, and destination markers. An empty ocean still has waves, weather, currents, and a world beneath. But empty intergalactic space is empty in a more radical sense. It is a place where structure thins until almost nothing remains except distance itself. Even temperature behaves strangely out there. Space is often called cold, but that word also hides complexity. A thermometer in deep space is not experiencing cold the way your skin experiences winter air. There is almost no matter to carry heat in the ordinary way. Yet a spacecraft still must manage temperature carefully, because the absence of atmosphere changes how heat is gained and lost. In sunlight, surfaces can become intensely hot. In shadow, they can become extremely cold. Heat must be controlled internally. In a journey lasting unimaginably long spans, this does not become easier. It becomes one more patient problem that never leaves. And then there is radiation. Even far from stars, intergalactic space is not some perfect peaceful void. High-energy particles move through the cosmos. Background radiation fills all of space. Violent events from distant regions send energy outward across unimaginable distances. There is no easy atmospheric shield out there, no planetary magnetic field to hide beneath. A spacecraft carrying life would need to create its own small island of protection and maintain it continuously over spans of time that defy ordinary engineering confidence. The deeper you think about it, the stranger it becomes. A trip to another galaxy would not just be long-distance travel. It would be the long-term maintenance of a tiny, self-contained pocket of order drifting through a realm that offers almost nothing in return. And that changes the meaning of failure. On Earth, most failures happen within reach of some other system. If a car breaks down, a road still exists. If a plane fails, rescue is at least imaginable. Even a ship on a lonely sea remains on a planet full of life, matter, and nearby destinations compared with the deep universe. But in intergalactic space, failure would not simply mean delay. It could mean silent irrelevance. A drifting tomb in an ocean with no shore. That sounds dramatic, but it is not meant that way. It is just the logical shape of extreme emptiness. When nothing is around you, the consequences of losing function become absolute very quickly. And still, the strangest part may be psychological rather than mechanical. Human beings evolved in rich environments, even harsh ones. Forests, plains, coastlines, deserts, mountains. Places with sound, variation, weather, ground, and horizon. Even the most isolated human lives on Earth unfold inside a living world. There is birdsong somewhere, wind somewhere, changing light, seasons, gravity, dust, memory, and the soft reassurance that one belongs to a world bigger than one room. Intergalactic space would remove nearly all of that. No weather crossing a distant valley. No living horizon. No landscape. No natural day and night unless you simulate them. No open sky in the human sense. Only systems, walls, routine, and the knowledge that outside your protected shell is a darkness so vast and so empty that language begins to lose its grip. It is possible, of course, that future humans, or something descended from humans, could adapt to such a life better than we imagine. Habit can turn strange conditions into ordinary ones. Culture can grow inside confinement. Meaning can be created, even in unnatural places. But even then, the emptiness outside would remain a silent fact. And that fact leads to another quiet realization. Between galaxies, there may be almost nothing to discover in the romantic sense people often imagine. Not nothing at all, because the universe is rarely that simple. There are diffuse gases, subtle structures, perhaps rogue objects, maybe rare wanderers cast out from galaxies, and deep information hidden in the thin material between cosmic systems. Science would still find wonders there. But for the traveler seeking the emotional satisfaction of exploration, the middle may feel almost mercilessly uneventful. Not because the universe has become uninteresting, but because its interest has become too subtle for ordinary experience. The average person imagines exploration as encounter. You go somewhere and meet something new. A new coastline. A new world. A new mountain range. a new species, a new sky. But what if exploration sometimes means crossing a vastness defined mostly by the absence of encounter? What if the journey beyond our galaxy is not a thrilling procession of cosmic landmarks, but an almost unbearable lesson in how empty the universe can be? That possibility matters because it changes the emotional promise of the mission. The dream of traveling outward often depends on a hidden assumption that farther means richer. That the universe will reward the voyager with wonder at every step. And in many places, it might. But the space between galaxies may do the opposite. It may force the voyager to live for ages inside a stretch of reality where wonder is too distant to touch, and where the main event is endurance itself. There is an irony here. We tend to fear crowded danger. Fire, impact, war, predators, storms, collapse. Things with force and urgency. But the universe may sometimes pose its hardest challenge through indifference. Not a barrier, but a gap. Not an attack, but an absence. Not a violent end, but a slow crossing with almost nothing to lean on. That is what intergalactic emptiness really is. A test of whether a fragile island of life and intention can carry itself across a desert so large that even light needs millions of years to finish the sentence. And if you let that image settle for a moment, another question begins to rise. Could there ever be a shortcut? Could we sleep through it, skip across it, fold it somehow, leap through physics in ways we do not yet understand? Maybe. Human imagination has always moved faster than human engineering. Ideas like suspended animation, generation ships, wormholes, warp drives, and other elegant escapes tend to appear whenever distance becomes emotionally intolerable. And perhaps someday some of those ideas will prove less impossible than they seem now. But for the moment, if we stay close to known reality, the emptiness remains what it is. A vast span that cannot be negotiated through optimism alone. Even the local group, the small cluster of galaxies that includes the Milky Way and Andromeda, is not some tightly packed cosmic city. It is a loose gathering spread across millions of light years. Galaxies themselves are giant islands, and even neighboring islands are separated by gulfs so wide that nearby becomes a very misleading word. Nearby, in the universe, can still mean unimaginably far. This is one of the quiet tricks of astronomy. Language keeps using familiar words while the scale underneath them becomes alien. Near, neighbor, local, empty. None of them mean quite what they mean in ordinary life. And perhaps that is why the journey between galaxies is so easy to underestimate. Not because the facts are hidden, but because the words remain deceptively gentle. The nearest major galaxy. The local group. Intergalactic medium. Empty space. Each phrase sounds manageable until you stop and translate it back into lived meaning. 2.5 million years for light. No atmosphere. No nearby rescue. No natural shelter. No meaningful landmarks for ages. A self-contained world carrying its own warmth, biology, memory, and purpose through a darkness that offers almost nothing. At that point, the phrase, space between galaxies, begins to lose its softness. It becomes what it really is. One of the largest and loneliest environments a conscious being could ever attempt to cross. And yet, strangely, there is also something beautiful about that truth. Because emptiness is not the same as worthlessness. The deep dark between galaxies is part of the universe's architecture. It is not wasted space. It is the grand interval that helps define the islands of light. Without vast darkness, galaxies would not appear as they do. Their separateness, their form, their identity all depend on the gulf around them. Silence is part of the music. Distance is part of the design. From far enough away, the universe is not a crowded city. It is an archipelago of luminous structures suspended across overwhelming dark. To exist at all within such a universe is already extraordinary. To understand even a little of it is more extraordinary still. But understanding does not make crossing easier. If anything, it makes the challenge more honest. Because now the dream is stripped of its comforting blur. Now we see that beyond the Milky Way lies not simply adventure, but a nearly unimaginable emptiness. A stretch of cosmic night so wide and so sparse that it may change not only what a journey requires, but what a journey even means. And that is only one part of the problem. Because even if a traveler could endure the emptiness, survive the silence, and maintain a tiny world across the dark, there would still remain a more familiar, brutal limit waiting beneath everything else. Speed. Not poetic speed. Not cinematic speed. But the hard physical limit on how fast anything carrying mass can actually go. And once that limit enters the story, the emptiness between galaxies stops feeling merely lonely. It starts feeling endless. Part 4. Why speed is our first great limitation. It is tempting to think the problem is simple. If another galaxy is too far away, then all we really need is a faster ship. That idea feels natural. It belongs to the same part of the mind that looks at every long journey and turns it into a question of pace. If the road is long, drive faster. If the ocean is wide, build a stronger engine. If the destination is remote, then perhaps the only real barrier is that our current machines are still too slow. And for a while, that thought feels comforting. Because if speed is only a technology problem, then maybe time will solve it. Maybe a future civilization, more advanced than ours, will simply build something powerful enough to erase the difficulty. Something elegant, quiet, and unimaginably fast. Something that makes the impossible feel ordinary. But the deeper you go into this question, the stranger it becomes. Because speed is not just another engineering challenge waiting patiently to be solved. It is one of the first places where the universe stops negotiating with us. There are many things human beings do not yet know how to do, but speed belongs to a different category. It is not just limited by our current tools. It is shaped by the structure of reality itself. And that is what makes it such a profound problem for any journey beyond our galaxy. If these slow explorations help you relax, you can always leave a like, subscribe, or share a thought in the comments later on. I always enjoy seeing which part of the universe feels most impossible and most beautiful to different people. The issue begins with a quiet misunderstanding. In everyday life, speed feels relative in a very forgiving way. A child thinks a bicycle is fast. A driver thinks the highway is fast. A pilot thinks differently. An astronaut differently still. So when we hear that something is far away in space, our instincts tell us that the solution is simply to keep moving up the ladder. Faster than a plane. Faster than a rocket. Faster than anything we have now. And that is true, for a while. But the universe is not built like an endless highway where speed can always be increased one more step without consequence. To feel this properly, it helps to begin with a familiar comparison. The Earth moves around the Sun at about 30 kilometers per second. We do not feel it, but we are already moving through space very quickly. The Sun itself is orbiting the center of the Milky Way at roughly 220 kilometers per second. Again, we do not feel it, but our entire solar system is already part of a fast cosmic motion. Human-made machines, however, live on a different scale. A commercial airliner moves at something like 900 kilometers per hour. A rifle bullet moves faster than sound, but only by a few kilometers each second. Even our most powerful spacecraft, by cosmic standards, are barely beginning to crawl. Voyager 1, which humanity launched in 1977, is one of the fastest and most distant objects we have ever sent into space. It is moving outward at roughly 17 kilometers per second relative to the Sun. That sounds extraordinary, and it is. But against the scale of interstellar and intergalactic space, it is still almost motionless. At that speed, reaching the nearest star would take tens of thousands of years. And the nearest major galaxy, Andromeda, is not 4 light-years away. It is about 2.5 million light-years away. The gap between those two statements is where the dream begins to change. Because once you move from stars to galaxies, ordinary language about speed begins to fail. We are no longer talking about making a trip shorter by some useful margin. We are talking about whether any non-imaginary speed could make the trip meaningful at all. Suppose, for a moment, that you could somehow travel at the speed of Voyager 1 forever. No breakdowns, no fuel problem, no navigation error, no need to stop, no aging, just motion, quiet, steady motion across the dark. How long would it take to reach Andromeda? Not centuries, not millennia, much longer than that. It would take tens of billions of years. That is longer than the current age of the universe. And that detail is important, because it tells us something fundamental. The problem is not that our machines are slightly too slow. It is that the scale of the universe has already outrun ordinary travel by such an absurd margin that improving our current methods is not enough. A better engine is not the same thing as a meaningful solution. So naturally, the mind moves to the next step. Fine, then. Not Voyager speed. Something far faster. Something dramatic. Maybe 1% of the speed of light. That still sounds almost mythical, but let us stay with it. Light travels at nearly 300,000 kilometers per second. So 1% of that would already be around 3,000 kilometers per second. A ship moving that fast would be far beyond anything humanity has ever built. And yet even at 1% of light speed, the journey to Andromeda would take about 250 million years. That is not a typo. 250 million years. At 10% of light speed, which is even more extreme, the trip would still take around 25 million years. At half the speed of light, a breathtaking and almost absurd velocity, the trip would still take roughly 5 million years from the perspective of an outside observer. And suddenly the emotional shape of the problem becomes clear. The issue is not only that space is empty. It is that the distances are so great that even speeds which feel almost divine on a human scale still leave us trapped inside cosmic time. That is why speed becomes the first great limitation. Because when most people say, we just need to go faster, they are still thinking like beings shaped by roads, oceans, and planets. They are imagining a bigger version of ordinary motion. But the universe does not merely ask for more speed. It asks for a completely different relationship with time, energy, and physics. And that brings us to the most famous limit of all, the speed of light. It is often described as the universal speed limit, and that phrase is useful, but it can sound too casual, almost like a speed sign placed by nature on a cosmic highway. In reality, it is stranger than that. The speed of light is not just a practical limit. It is woven into the structure of spacetime itself. According to everything we currently understand, no object with mass can be accelerated to the speed of light. Not because we are not advanced enough. Not because we have not yet invented the correct engine. But because mass and light do not belong to the same category of motion. This is one of those moments in science where the truth sounds almost unfairly simple. The faster you try to push an object with mass, the harder it becomes to push it faster still. As it approaches light speed, the energy required does not increase gently. It climbs more and more severely. To actually reach light speed would require an effectively impossible amount of energy. In other words, the closer you get to the limit, the more the universe tightens its grip. There is something almost poetic about that. For thousands of years, human beings have outrun one limit after another. We crossed deserts, oceans, mountain ranges, sound barriers, and planetary boundaries. So it is natural for us to imagine that every frontier is temporary. That every wall is just waiting for its engineer. But light speed does not behave like an old wall waiting to be broken. It behaves more like a horizon that recedes into impossibility the closer you approach it. That does not mean travel near light speed is meaningless. It is not. Even getting to 10% or 20% of light speed would transform what is reachable within a galaxy. It would change the future of interstellar exploration completely. But when the subject is another galaxy, even these astonishing speeds do not rescue us as cleanly as intuition hopes. And there is another problem hiding behind this: acceleration. Whenever people imagine a very fast spacecraft, they often picture the final speed, not the process of getting there. But reaching a huge velocity is not the same as instantly possessing it. You must accelerate. That takes time, energy, and tolerable conditions for whatever is inside the craft. If a human crew were aboard, that matters even more. The human body is not an abstract point in a physics equation. It is fragile. It can handle some acceleration, but not indefinitely, and certainly not without consequence if conditions become extreme. A gentle acceleration might be survivable, but then the time needed to build up to enormous speeds becomes part of the journey. A stronger acceleration shortens that time, but creates new physical stress. And once you finally arrive near your destination, there is another often forgotten requirement. You must slow down. A journey is not just a matter of pointing yourself at another galaxy and firing the engine once. If you want to arrive in any meaningful sense, rather than simply rush through the outer regions at impossible speed, you also need the energy and time to decelerate. Every problem of acceleration has a twin waiting at the other end, and that doubles the emotional weight of the challenge, because now speed is no longer just a number. It is a long process of careful force, sustained power, and survival. There is a very human habit of imagining future technology as magic with metal around it. A beautiful ship gliding silently through space, somehow protected from the full cost of the laws it is obeying. But real speed is expensive. It is demanding. It creates heat. It demands energy. It magnifies error. It turns tiny collisions into catastrophe. That last part is especially important. Space, even interstellar and intergalactic space, is not perfectly empty. It contains sparse atoms, dust grains, high-energy particles, radiation, and occasional debris. Usually, when we hear that space is almost empty, it sounds helpful. Fewer things to hit, more room to move. But at very high speeds, even almost nothing becomes dangerous. A tiny grain of dust at ordinary relative speeds may be irrelevant. The same grain encountered at a significant fraction of the speed of light becomes something else entirely. Not a harmless speck, but an impact carrying enormous energy. This is one of the more haunting truths about extreme speed. The faster you move, the more the emptiness itself becomes a hazard. You are no longer just traveling through space. You are striking whatever is there with increasing violence. And because the universe offers no easy roadside assistance, shielding becomes a major issue. How much protection would a ship need against particle impacts, radiation, and long-term wear at relativistic speed? How heavy would that shielding be? How much energy would be needed to accelerate that heavier ship? Each answer makes the next question harder. The problem begins to fold in on itself. To go faster, you may need more energy. To protect yourself at that speed, you may need more mass. More mass requires more energy. More energy may require larger systems. Larger systems may create more maintenance demands. And all of it must function not for a brief sprint, but for durations that may still stretch beyond anything human civilization has ever sustained. There is another strange side to speed that people often hear about but rarely feel in a deep way. Time dilation. This is the part of relativity that enters popular imagination because it sounds almost like a loophole. If a traveler moves close enough to the speed of light, time for that traveler passes more slowly relative to those who remain behind. In principle, this means a very fast journey could feel shorter for the crew than it does for the rest of the universe. And that is true. It is one of the most beautiful and unsettling features of modern physics. The faster you move, the more differently time behaves for you relative to others. So a person traveling at an extreme fraction of light speed might experience a journey as shorter than distant observers would calculate. At first, this sounds like the answer. Maybe the trip to another galaxy is still possible, at least from the traveler's point of view. But even here, the comfort is incomplete. Because time dilation does not erase the energy problem. It does not erase acceleration. It does not erase impact hazards, shielding, engineering endurance, or the need to survive at those speeds in the first place. It also does not change what happens to the world left behind. A traveler might experience a smaller slice of personal time, but by the time they arrived, millions of years might have passed outside their frame. Everything they came from would be gone, not changed in some mild and familiar way, but gone beyond emotional recognition. Continents, languages, species, memories, civilizations, perhaps even the conditions of life on Earth itself, all of it transformed or erased by time. So even if speed rescues the individual experience, it may destroy the idea of a connected mission. Who leaves, and who arrives, begin to separate more radically than ever. And if the goal of the journey was not just personal transit, but the continuation of human meaning across space, that matters deeply. Speed near light is not just a technical feat. It is a form of temporal exile. This is why the limitation of speed is so profound. It does not merely slow us down. It changes the meaning of departure, arrival, and continuity. Even communication suffers under this reality. We often imagine exploration as a conversation between the explorers and home. Messages sent back, guidance received, a continuing thread of shared purpose. But at intergalactic distances, communication is bound by the same limit as everything else, light speed. A message to Andromeda takes 5 million years one way. Not because our transmitters are weak, not because we have not built powerful enough antennas, but because information itself cannot outrun the fabric of spacetime. So a ship heading beyond the Milky Way would eventually leave not just the comfort of home, but any practical relationship with it. No live contact, no rescue planning, no responsive guidance, only autonomy, memory, and whatever systems it carries within itself. Again, speed is not just about motion. It is about what can remain connected while motion occurs. The more honestly we look at it, the more speed seems less like a ladder and more like a narrowing corridor. Yes, go faster, and some things become reachable. But other things become more dangerous, more expensive, more isolated, and more physically demanding. Faster is not a pure good. It is a trade. And sometimes, at cosmic scale, the trade becomes almost impossible to justify. There is a quiet sadness in that, but also a kind of clarity. Because once we stop treating speed like a magic cure, we begin to see the real shape of the universe. The cosmos is not withholding other galaxies from us out of cruelty. It is simply structured on scales that do not care about the desires of a short-lived species. It allows movement, but not movement without cost. It allows ambition, but not ambition without physics. And perhaps that is part of the beauty too. It reminds us that nature is not built around our instincts. The human mind loves the idea that enough determination can overcome any distance. On Earth, that belief has often served us well. It helped our ancestors cross landscapes, seas, and ages of uncertainty. But the universe beyond the galaxy asks a gentler and harsher question. Not how badly do you want to go, but what does going actually require? And when that question is asked honestly, speed becomes the first great answer. It requires more than a better engine. It requires more than courage. It requires a negotiation with the deepest rules we know, and perhaps some rules we do not yet understand. Maybe one day some civilization, human or otherwise, will discover a way to cross immense distances without paying the full familiar price of speed. Maybe spacetime itself has possibilities we have not yet learned to use. Maybe the story is not finished. Science has surprised us before, and humility demands that we leave some room for what we do not know. But if we stay close to the physics we understand now, the picture remains severe. The distances between galaxies are so enormous that ordinary spacecraft speeds are meaningless. Speeds that seem astonishing to us remain slow compared with the task. Approaching light speed creates crushing energy demands. High velocities turn sparse matter into lethal impact. Acceleration and deceleration become major survival problems. Time dilation helps the traveler, but deepens separation from everything left behind. And communication itself is trapped under the same universal limit. So when people imagine a future ship simply going faster until another galaxy comes within reach, they are imagining a story the universe may not be willing to tell. That does not make the dream foolish, only expensive in truth. And maybe that is enough for tonight. To sit quietly with the idea that speed, which feels so empowering in ordinary life, becomes something very different at cosmic scale. Not freedom, exactly. Not victory. More like a negotiation with reality, in which every increase must be paid for somewhere else. Beyond our galaxy, the dark is not just empty. It is distant in a way that forces speed to reveal its limits. And once those limits begin to settle into view, another problem slowly emerges from behind them. Even if we could move far faster than we do now, even if we could build something patient and durable enough to cross the dark, there would still remain another question waiting inside the ship itself. Not how fast it moves, but whether living beings like us could survive the journey at all. Part 5: The energy problem of a journey that never seems to end. There is a quiet moment in almost every dream of deep space travel when the imagination does something kind. It shows us the ship, not the equations, not the fuel, not the decades of preparation, or the impossible engineering, or the patient violence required to push matter across the dark. Just the ship itself. Elegant, self-contained, gliding in silence. A bright little world moving calmly through the black. And for a moment, that image makes the whole idea feel easier than it really is. Because once the ship exists in the mind, once it is already moving, the hardest part seems finished. The journey begins to feel like a matter of patience. Just keep going long enough, and eventually another galaxy will appear ahead. The problem feels emotional, perhaps even poetic, but no longer physical in the same brutal way. Yet this is where one of the deepest difficulties quietly returns. Because a ship moving through space is never just a ship. It is stored energy becoming motion. It is power being spent, managed, lost, redirected, and protected. It is a machine trying to preserve a tiny pocket of order while obeying the strictest rules in nature. And the farther the journey, the more severe that truth becomes. In ordinary life, energy often hides behind convenience. We flip a switch and light appears. We press a pedal and the car moves. We charge a phone while sleeping. We boil water, cool a room, ride an elevator, board a plane, and rarely pause to feel the scale of the hidden systems working underneath it all. Modern life is full of invisible energy made ordinary. But space has a way of removing that comfort. Out there, especially on a journey beyond the Milky Way, nothing is ordinary for long. Every bit of motion must be paid for. Every protected degree of warmth. Every controlled breath. Every repair. Every correction in direction. Every effort to keep life going inside a vessel surrounded by enormous indifference. And once you begin to feel that, the problem changes shape again. It is not only that another galaxy is far away. It is that the journey asks for energy on a scale so immense that even imagining it honestly becomes difficult. If you enjoy these slow and quiet walks through the universe, you can always leave a like, subscribe, or share a thought in the comments when you feel like it. I always like hearing which ideas stay with people the longest, especially the ones that seem simple at first and then grow heavier in the silence. The most basic version of the energy problem is easy to say. To move something faster, you need energy. The more massive the thing is, and the faster you want it to go, the more energy you must give it. That sounds straightforward, almost too obvious to matter. But in deep space travel, that simple truth grows into something enormous. A spacecraft meant to cross the gulf between galaxies would not be a small thing. Even if it carried no human crew, it would need systems, shielding, structure, navigation, communication, and some reliable way to remain functional over absurd spans of time. If it carried life, then the demands grow even larger. Air, water, temperature control, waste management, radiation protection, food production or storage, medical capability, maintenance tools, spare parts, and a stable environment would all become part of the ship's burden. And burden matters, because burden has mass. Mass is what the engine must push. So the moment you imagine a craft robust enough to survive the true journey, you are no longer imagining a sleek arrow in the dark. You are imagining a moving habitat, a machine carrying not just bodies, but an entire strategy for resisting death over spans of time that stretch far past anything our civilization has ever sustained. And the larger that machine becomes, the more energy is needed to accelerate it. That is the first trap. The ship must be substantial because the journey is extreme. But the more substantial the ship, the harder it becomes to move at the speed required to make the journey meaningful. On Earth, we solve versions of this problem every day. Larger trucks need more fuel. Bigger airplanes burn more energy. Heavier objects resist acceleration. But on Earth, the distances are forgiving enough that these problems remain practical. We can build bigger engines. We can refuel. We can return to port. There is always some nearby system feeding the effort. Intergalactic travel removes that comfort. The distances are so severe that the energy problem stops being an engineering inconvenience and becomes part of the central mystery. How do you push a self-contained world across a darkness measured not in miles or months, but in millions of light years? There is a very old idea hiding in human thought, and it appears whenever distance becomes overwhelming. The idea is that power will save us. That if something is far enough away, difficult enough, or grand enough, then somewhere there must exist a machine strong enough to crush the problem through sheer force. A bigger engine, a brighter flame, a deeper reservoir. But the universe is not always moved by that kind of confidence. Sometimes the scale is so large that force itself becomes the thing you run out of first. One of the simplest ways to feel this is to think about fuel, not in a technical sense, but in a physical one. A machine that accelerates through space generally needs to throw something backward in order to move forward, unless it relies on some external push like light pressure or gravitational assists. Rockets work by carrying propellant and expelling it. The more speed you want, the more propellant you tend to need. And here a brutal logic appears. Fuel has mass, which means the fuel itself makes the spacecraft heavier. So to accelerate the fuel, you need more fuel. And to accelerate that additional fuel, you need still more. This is one of the reasons rocket design becomes so unforgiving. The energy needed for a journey is not just stored in fuel. The fuel changes the size and burden of the machine that must carry it. The farther and faster you want to go, the more the system swells under its own requirements. On short missions, or even on missions within a solar system, this is already challenging. On a journey beyond the galaxy, it becomes something else entirely. You begin to encounter what feels like a kind of geometric cruelty. Every attempt to solve the problem by adding more capability often adds more mass, which then increases the energy problem, which then demands more mass again. The ship becomes a machine built to support its own need to keep existing. That does not mean clever designs are impossible. Human beings are very good at finding elegant workarounds. We can imagine nuclear propulsion, fusion systems, antimatter concepts, beam-powered sails, giant laser pushes, harvesting resources in advance, and many other ideas that try to escape the ordinary tyranny of rocket fuel. And some of these ideas are scientifically serious enough to deserve respect. But even when you grant the most generous future technology, the emotional truth remains. None of these ideas remove the cost. They only change the way the cost appears. Energy never disappears from the story. A beam-powered sail, for example, might allow a spacecraft to avoid carrying all its own fuel. But then the energy must come from somewhere else, in staggeringly concentrated form, over huge distances, with extraordinary precision. A nuclear or fusion-powered ship might draw from denser energy sources than chemical rockets. But then the ship must safely contain and manage those reactions for immense spans of time. Antimatter, if it could ever be produced and stored at useful scales, would offer extraordinary energy density. But that only shifts the problem into production, storage, stability, and safety. In every version of the story, energy remains the price of motion. And the more honestly we imagine another galaxy, the higher that price rises. There is another layer to this problem that is easy to miss if we think only about the beginning of the trip. We imagine the launch, the acceleration, the dramatic push out into the dark. But journeys are not powered only at the start. A real mission would almost certainly need continuous energy long after the initial burst of speed. Life support takes energy. Navigation takes energy. Communication takes energy. Computation takes energy. Thermal control takes energy. Repairs take energy. Artificial gravity, if it were ever created aboard such a ship, would take energy or impose some equally heavy design cost. Farming, water recycling, air circulation, lighting, manufacturing replacement parts, monitoring disease, protecting systems from radiation, and maintaining social structure inside a sealed environment, all of that has an energy price. The ship is not just moving. It is living, or at least trying to preserve the conditions under which life can continue. That may be the most underappreciated part of the whole dream. A deep space vessel is not like a bullet. It is more like a village that has agreed to become a machine. And villages do not survive on speed alone. They survive on continuous work. They survive on systems that wake up every day and keep doing what must be done. Even on Earth, where sunlight falls freely on the planet, where air surrounds us, where oceans and weather cycles support life, where soils and ecosystems do work on our behalf, keeping civilization alive is a constant energy project. Cities consume enormous power just to remain cities. Water must move. Food must be grown and transported. Waste must be handled. Rooms must be heated or cooled. Networks must stay awake. Hospitals must remain sterile. Data must flow. Refrigerators hum through the night. Now imagine all of that compressed into a sealed ship crossing a cosmic desert. It is not enough to leave. You must keep leaving, every day, for centuries or millennia or longer. The ship becomes not a one-time act of engineering, but an endless argument against entropy. And entropy never sleeps. This is a word that sometimes sounds technical, but its emotional meaning is simple. Left alone, ordered things tend to become less ordered. Heat spreads. Structures wear down. Systems drift. Metal fatigues. Lubricants degrade. Materials crack. Stored energy leaks away into unusable forms. Machines require maintenance because the universe has no interest in preserving arrangement for free. On Earth, we fight entropy with constant access to matter and energy. We mine, refine, repair, replace, import, export, rebuild, and redesign. A failing part can often be swapped. A sick system can often be fed from somewhere else. Even when resources feel scarce to us, we are still standing on a full planet. A ship between galaxies would not have that luxury. It would need to carry not only the means of survival, but the means of repairing survival. It would need tools to fix tools, systems to remake systems, knowledge to preserve knowledge, and enough energy to keep all of it functioning while the long dark continued outside. And because the journey is so long, even small inefficiencies become large. A tiny daily energy loss, almost meaningless across a week or a year, becomes severe across centuries. Waste heat matters. Friction matters. Microscopic damage matters. The reliability of seals, circuits, bearings, processors, and structural materials matters. And all the while, the mission is burning not just fuel, but time itself. There is something deeply quiet about that thought. A spacecraft on such a mission would not be heroically sprinting through the stars. It would be enduring, conserving, balancing, spending just enough, never too much, guarding every reserve like winter food in a landscape with no spring. This is why energy is not merely a technical topic here. It shapes the mood of the entire journey. A world with abundant energy feels open. It can improvise. It can afford mistakes. It can build beauty, experimentation, comfort, and play. A world with scarce energy becomes something else. It narrows. It watches. It measures. It becomes cautious. And that has consequences not just for machines, but for minds. Imagine living aboard a vessel where every choice is shaped by a long-term energy discipline. Lights carefully managed. Temperature tightly controlled. Recreation limited by power cost. Manufacturing scheduled. Systems prioritized. Emergencies feared not only because of danger, but because emergencies consume reserves. Even if the ship were comfortable by any rational standard, the culture inside it might slowly become shaped by a constant awareness that motion itself is expensive, life itself is expensive, and waste is a form of threat. The farther the destination, the more sacred efficiency becomes. There is also the question of where energy can be replenished, if anywhere. Inside a solar system, a ship might use sunlight. It might gather resources from planets, moons, asteroids, or comets. It might use gravitational assists from large bodies. It might choose routes that allow partial renewal. But between galaxies, those advantages fade. The farther from stars you travel, the weaker starlight becomes as a practical power source. The emptiness that defines intergalactic space also means there are few convenient places to refill, repair, or rebuild. This makes the journey feel less like travel and more like exile from supply. You must bring what you need, generate what you can, recycle what you use, and endure what you cannot replace. The dream of an endlessly moving ship often forgets this. Movement suggests freedom, but at great distance movement can lock you into dependence on whatever energy strategy you chose at the beginning. A bad design choice made early may remain with you for generations. A system that seemed good enough in theory may prove fragile in practice. And because communication with home would be trapped by light speed, advice from those left behind might arrive only as archaeology. There is another brutal truth hidden in all of this. High speed is not just hard to achieve, it is hard to stop. If a ship is somehow accelerated to a meaningful fraction of light speed, then arrival itself requires another enormous energy event. You do not simply coast into another galaxy and park gently. To truly arrive, to become part of the destination rather than a projectile passing through it, you must decelerate. That means the journey has two great energy cliffs, not one. The first is leaving. The second is not overshooting. And if you want the voyage to be survivable and useful, you must somehow pay for both. This doubles the depth of the problem in a very human way. It is like saving enough not only to leave home forever, but to build a new home at the far edge of time. The mission cannot spend everything on escape. It must also reserve enough for belonging at the end. When people imagine intergalactic travel, they often picture the romance of distance, the courage of leaving, the triumph of movement. But energy forces us into a quieter honesty. Every beautiful image of departure hides an immense accounting ledger beneath it. Every kilometer per second has a cost. Every shielded room has a cost. Every preserved life has a cost. Every year of continued order has a cost. The farther the dream stretches, the more the ledger begins to dominate the story. And then something even stranger happens. The energy problem becomes a time problem. Because if your ship must conserve, if every reserve must be protected, then speed may be traded against endurance. Perhaps you travel slower to reduce stress and cost. But then the journey lasts longer, which means life support and maintenance systems must function longer, which increases the total burden of survival. If instead you travel faster, you may shorten the experienced duration, but only by demanding much greater energy up front and facing higher risk from impacts, heat, radiation, and system strain. There is no version of the story that feels free. Spend more to shorten the dark. Spend less and live in the dark longer. The mission is caught between appetite and patience. Even in imagination, that is exhausting. And yet, perhaps the hardest thing to accept is not that the numbers are large, but that the universe never promised a discount. Human beings often assume that greater wisdom will eventually reveal a cleaner trick, a hidden efficiency, a secret fold in nature that turns impossible journeys into elegant ones. And perhaps someday it will. It would be foolish to pretend the future has no surprises left. But for now, the known universe seems to say something much plainer. Distance is expensive. Not metaphorically. Not psychologically. Physically. To cross the dark, you must feed motion. To preserve life, you must feed order. To resist entropy, you must feed systems. To arrive, you must feed braking as well as acceleration. And the farther the dream reaches, the more relentlessly these costs accumulate. There is something almost ancient in that truth. Long before rockets, long before astronomy, long before human beings understood galaxies at all, our ancestors already knew that journeys consume more than courage. They consume food, tools, time, health, coordination, trust, and the ability to keep going when the destination still feels unreal. The scale has changed, but the logic has not. A journey beyond the Milky Way is still a journey, which means it still obeys the oldest law of travel. You must carry what keeps you alive until the world changes around you. And in this case, the world may not change around you for an impossibly long time. That is what makes the energy problem so haunting. It does not arrive with one dramatic explosion. It arrives as a slow, persistent demand. A demand that follows every stage of the trip. A demand that touches motion, survival, identity, and hope. A demand so patient that the mission might come to feel less like exploration and more like an unbroken act of budgeting against the universe itself. Maybe that is why so many visions of deep space quietly depend on miracles. Infinite reactors, perfect engines, effortless hibernation, hidden shortcuts in space-time. Not because imagination is weak, but because the known costs are so intimidating that the mind naturally looks for mercy somewhere. And maybe mercy exists somewhere in the laws we have not yet discovered. But if we stay with what we know, the picture is sobering and strangely beautiful. Another galaxy is not merely far away. It is energetically far away. It asks not only where you are going, but how long you can continue paying for the fact that you are still going at all. So the journey beyond our galaxy is not just a question of navigation or courage or even speed. It is a question of whether a fragile civilization can gather, preserve, and wisely spend enough energy to keep a tiny living world in motion across a darkness that never once offers to help. And once that truth settles in, another question begins to feel even heavier. Even if the ship could be powered, even if the systems could endure, even if the long account of energy could somehow be paid, what about the passengers themselves? What about the bodies, the minds, the generations, and the quiet human need to remain human while the journey keeps stretching on? Because in the end, a ship is only a shell. And beyond the shell waits the deeper problem of whether living beings like us could survive the trip as we are now. Part 6: Why humans may not survive the trip as we are now. There is a version of the dream that feels very human. A ship leaves the Milky Way. A crew is aboard. They look back one last time at the soft band of their home galaxy, then turn their attention toward the dark ahead. The journey is long, of course, but still recognizable as a journey. There are people on board. There is a mission. There is courage, discipline, maybe even wonder. And one day, far in the future, those same travelers arrive. It is a beautiful image. And perhaps that is exactly why it is so difficult to let go of. Because once we begin talking about intergalactic travel, the mind naturally wants to keep the story personal. It wants faces. It wants sleepers in quiet rooms, conversations in narrow corridors, the steady hum of life support systems, the old human pattern of leaving one place and hoping to reach another. But the deeper we look, the more fragile that version becomes. Not because human beings are weak in any simple sense. We are adaptable, inventive, stubborn creatures. We live in deserts, mountains, frozen landscapes, crowded cities, submarines, research stations, and orbiting laboratories. We survive surgeries, storms, wars, pandemics, and grief. We have an extraordinary talent for carrying life into places that do not easily welcome it. And yet the journey beyond our galaxy may ask for something even our best qualities cannot fully provide. It may ask us to survive not just danger, but duration. Not just hardship, but timescales so long that the human body, the human mind, and perhaps even the idea of a single human mission begin to come apart. If these slow reflections help you unwind, you can always leave a like, subscribe, or share a thought in the comments later on. I always enjoy seeing what part of the universe lingers in people's minds when the room gets quiet. The first and simplest problem is lifespan. Human beings do not live very long. That is not meant sadly. It is just true. Even in the healthiest cases, a human life is brief when measured against the distances between galaxies. We think in decades because that is what our bodies allow. A long life might stretch across 80 or 90 years. A rare life may reach beyond that. But even the longest human life is still tiny beside the kind of journey we are describing. If a destination lies millions of light years away, then even a ship moving at extraordinary speed would almost certainly require more time than one ordinary human life could hold. In many cases, far more. And that alone begins to dissolve the familiar version of the story. Because a journey that outlasts the traveler is not a journey in the ordinary human sense. It becomes something else. Something inherited rather than completed. Something carried forward rather than personally lived from beginning to end. On Earth, we can accept that some projects outlive the people who begin them. Cathedrals took centuries to build. Languages evolve over long spans of time. Nations inherit the dreams and mistakes of earlier generations. But the physical experience of travel has usually remained personal. You leave, you endure, you arrive. A trip beyond the Milky Way may break that pattern completely. And even before lifespan ends the story, the body begins to struggle in other ways. Human beings are products of Earth. That truth sounds obvious, almost too obvious, until you really sit with it. Every part of the human body was shaped in the presence of gravity, atmosphere, weather, sunlight filtered by air, a stable day-night rhythm, a magnetic field that helps shield the planet from charged particles, and ecosystems so rich that we barely notice how much of our survival they manage for us. We are not just organisms living on Earth. We are Earth-specific organisms. Take us away from those conditions for a short time, and the body begins to change. We already know some of this from spaceflight. Astronauts in orbit do not simply float around as unchanged humans. Their muscles weaken if they are not carefully exercised. Their bones begin to lose density because the body is no longer bearing weight in the usual way. Fluids shift upward. The heart and blood vessels adapt to a different environment. Balance changes. Sleep can become more difficult. The immune system may behave differently. Vision can even be affected after long periods in microgravity. And that is after months in low Earth orbit, still relatively near home, still protected in part by Earth's broader environment, still in contact with civilization. Now imagine not months, but years. Not years, but generations. Not a short mission with constant support, but a sealed human habitat moving through deep space with no immediate return, no rescue, and no natural Earth waiting outside the door. The longer the trip becomes, the less we can pretend the body will simply endure it unchanged. Microgravity alone presents a quiet but severe problem. The human skeleton and musculature are not decorative. They exist inside a world where standing up costs effort, walking reshapes the body every day, and gravity constantly reminds tissues what they are for. Remove that long enough, and the body begins to economize in ways that are not helpful for life on a planet. Muscle shrinks because it is no longer needed in the same way. Bone weakens because the old stress is gone. This is efficient in a narrow biological sense, but dangerous if the goal is long-term health or eventual arrival in another gravitational environment. A person who spends too long in weightlessness is not simply resting from gravity. They are being remodeled by the absence of it. Some people imagine artificial gravity as the clean solution, and perhaps one day it will be part of any serious deep space design. Rotating habitats, for example, could in principle create a gravitational effect through centripetal motion. But even then, solutions bring their own burdens. They demand structure, precision, stability, energy, maintenance, and careful design. And on a ship built for immense duration, every additional system becomes one more long argument against failure. There is also radiation. On Earth, most of us never need to think about how protected we are. The atmosphere above us and the magnetic field surrounding the planet quietly do a remarkable amount of work. They absorb and deflect a great deal of harmful radiation that would otherwise reach the surface. Even here, radiation exists, of course. But the Earth softens the universe for us. Space does not. Beyond the shelter of Earth, radiation exposure becomes a more persistent concern. High-energy particles from the Sun, cosmic rays from far more distant events, and the general background harshness of space create a steady biological pressure. For short missions, we can manage and reduce some of the risk. For longer missions, the accumulated burden becomes harder to ignore. Radiation can damage cells. It can increase cancer risk. It can harm tissues slowly and invisibly. It can affect the brain as well as the rest of the body. Shielding helps, but shielding adds mass, and mass worsens the energy problem we already met earlier in the journey. So even here, every attempt to protect life pulls against another hard limit elsewhere. This is what makes intergalactic travel such a complete challenge. The problems are not separate. They hold on to each other. Biology, engineering, energy, psychology, and time all tied in together. And then there is the quieter problem of isolation. Human beings can survive many forms of difficulty, but one of the hardest to measure is the long, low pressure of being cut off. Not just physically far from home, but truly removed from any living world that feels larger than the system around you. A ship can provide company, structure, and routine, but it cannot easily replace a planet. That may sound sentimental, but it is also biological. We are not built only from organs and bones. We are pattern-seeking, socially shaped, environmentally responsive creatures. We regulate ourselves through touch, sunlight, seasons, changing landscapes, smells in the air, weather on the skin, unplanned encounters, familiar sounds, and 1,000 small reminders that we belong to a living world rather than a manufactured enclosure. Take those away for long enough, and the mind does not always respond gently. We already know isolation can alter people in powerful ways. Researchers in extreme environments, sailors on long voyages, submariners, polar crews, and astronauts all offer glimpses of what confinement and separation can do. Sleep can change. Mood can flatten. Irritability can rise. Motivation can fray. Small disagreements can grow large in sealed environments. Meaning itself can become harder to maintain when days blur together and the outer world offers no new horizon. And those are people on missions measured in months or perhaps a few years, often with the comfort that Earth still exists close enough to matter emotionally. A journey beyond our galaxy may demand something harsher. It may ask people to live and die in a place where Earth is not just far away, but functionally unreachable, beyond conversation, beyond rescue, beyond any normal experience of home. At some point, the emotional structure of return disappears. And once return disappears, the human mind must build a new kind of meaning to take its place. That is not impossible. Human beings are extraordinary meaning makers. We build rituals, stories, identities, and hopes even in hard places. But the scale of this separation remains difficult to overstate. It is one thing to miss home. It is another to know that home is now a memory held inside a ship, with no practical relationship to the world outside. The farther the mission stretches, the more the ship stops being transportation and starts becoming environment. And once the ship becomes environment, another issue begins to rise. Reproduction. This is a quiet subject, but it sits at the center of any truly long mission. If the journey cannot be completed within one lifetime, and if the goal is to carry humanity itself rather than a machine alone, then eventually the question appears. Can human beings safely reproduce in such an environment? Can embryos develop normally? Can children grow in partial gravity, artificial gravity, or prolonged weightlessness? What happens to development, immunity, bones, learning, mental health, and social stability across generations born far from any planet? The honest answer is that we do not know enough. And that uncertainty matters. Because it means we cannot casually assume that a multi-generational human journey through deep space would work just because adult humans can survive in space for a while. Reproduction is not just the continuation of life. It is one of the most sensitive biological processes there is. Small disturbances in environment can matter enormously. Growth depends on stable conditions. Brains develop in relationship with bodies, bodies with gravity, both with rhythm and care and time. A long intergalactic mission may eventually force humanity to answer a haunting possibility. Maybe humans, as we currently are not meant to reproduce well away from Earth at all. Maybe our biology carries deeper assumptions about gravity, radiation shielding, environmental stability, and planetary life than we have yet fully understood. And if that is true, then the journey does not merely challenge our machines. It challenges our species' design. There is another dimension to survival that feels almost philosophical, but it is practical too. Human beings need not only to stay alive, but to remain recognizably human in experience. That sounds abstract until you imagine the alternatives. A crew kept alive through heavy sedation for long spans. People living under extreme behavioral control so that systems and social order remain stable. Bodies genetically altered to withstand radiation and confinement better. Brains interfaced with machines so extensively that psychological endurance becomes partly engineered. Memories filtered, emotional range chemically managed, or identity reshaped to adapt to the mission. None of these ideas are impossible to imagine. In fact, once the challenge becomes honest enough, such possibilities almost begin to suggest themselves. If ordinary human beings cannot survive the trip, perhaps future humanity will change what ordinary means. And that may be true. But then another question appears, soft and difficult. If survival requires changing ourselves too deeply, who exactly is making the journey? Is it stillness in the sense we care about? Or is intergalactic travel only possible for descendants, modifications, or engineered beings so altered by necessity that the old picture of humans crossing the dark quietly fades away? There is no simple answer to that. Perhaps identity is more flexible than we think. Human beings have always changed through culture and technology. Glasses, medicine, surgery, language, education, writing, and machines already reshape what our species can do. So perhaps adaptation is not betrayal. Perhaps it is simply continuation by other means. Still, the question lingers. Can humans as we are now survive the trip? Not humans as an eventual redesigned civilization. Not post-human descendants adapted over millennia. But as the kind of human being who gets sleepy at night, misses home, needs routine, laughs at small things, grows old within decades, and carries a body built for Earth. The deeper we look, the more the answer seems uncertain at best. Even food becomes part of this uncertainty. A long journey would need a reliable food system, and food is never just calories. It is biology, culture, emotion, and logistics combined. Stored food degrades over time. Closed-loop agriculture in space is possible in principle, but it requires water cycling, light, nutrients, pollination strategies or substitutes, waste processing, disease control, and long-term ecological balance inside a confined environment. A ship that feeds people for centuries is not merely carrying supplies. It is carrying a managed ecosystem, or something close to one. And ecosystems are delicate. Even on Earth, where life has immense room and resilience, ecological balance can be disturbed. In a sealed environment, disturbances may be harder to absorb. Water, too, becomes a living concern. Not because water is rare in the universe in an absolute sense, but because usable, safe, recycled water inside a closed spacecraft is part of a continuous technological and biological dance. Purity must be maintained. Systems must work. Failure cannot be casual. On Earth, even when water systems break, there is still a planet around us. On a ship, there is only the ship. And then there is illness. Human beings do not stop being biological just because they leave home. Bodies still age. Cells still mutate. Teeth still fail. Mental illness can still emerge. Infections may still happen. Chronic conditions may still appear. Injuries may still occur. And medicine on a sealed deep space vessel would be medicine without the support web modern hospitals quietly depend on. No nearby specialists. No emergency imports. No quick replacement equipment. No large pharmaceutical supply chain constantly refreshing itself. Everything would have to be anticipated, carried, manufactured, or endured. The farther the journey, the more medicine becomes another branch of self-contained civilization rather than an emergency service. A human ship to another galaxy would need not just doctors, but durable medical culture. Knowledge preserved across generations. Tools maintained. Diagnostic systems kept accurate. Surgical capability perhaps. Psychological care. Genetic understanding. Preventive health. Rehabilitation. End-of-life rituals. Birth support. Palliative care. Because if the journey is long enough, the full cycle of human life will happen aboard. Children will be born. People will fall in love. People will grieve. People will lose parents. People will become old. People will die. And that means the ship must be more than a machine. It must be capable of being a society. That is where the question becomes especially quiet and heavy. Could a society remain healthy while sealed inside a moving structure for timescales beyond any ordinary historical comparison? Could conflict be contained? Could purpose survive? Could boredom be managed? Could education remain rich enough for new generations? Could authority remain legitimate? Could despair be kept from spreading in ways no engineering solution can repair? These are not side questions. They may be central. Because a journey does not fail only when engines fail. It can fail when meaning fails. When trust erodes. When institutions inside the ship become brittle. When the people no longer agree on why they are there. On Earth, social failure still happens in a world with horizons, migration, renewal, and contact between communities. On a sealed intergalactic vessel, social failure could become existential. And that may be one of the most human obstacles of all. Not distance. Not speed. Not even biology alone. But the challenge of carrying a stable and humane civilization inside a container too small for escape. Still, there is something strangely moving in this realization, because it reminds us that human survival is not simply a question of toughness. It is a question of context. We are resilient, yes, But our resilience has always been relational. It depends on systems bigger than ourselves, even when we do not notice them. Families, cities, fields, weather, oceans, microbes, forests, gravity, dawn, culture, memory, medicine, music, touch. We survive not as isolated units, but as participants in a world that quietly supports us. Take enough of that away, and the heroic image of humans striding into the stars begins to soften into something more truthful. We do not merely need a ship. We need an entire substitute world. And a substitute world is difficult to build, harder to preserve, and perhaps impossible to make fully equal to the one that shaped us. So when we ask whether humanity could ever complete a journey beyond the Milky Way, we are not only asking what engines can do. We are asking whether bodies made for Earth can remain healthy away from Earth, whether minds made for open worlds can stay whole in sealed ones, whether a short-lived species can endure timescales that dissolve the meaning of individual travel, whether the next generation could even grow properly in such a place, whether social life can remain human under conditions so unlike any home we have ever known. And if the honest answer is no, or not yet, then the dream changes again. It does not vanish, but it becomes less like a voyage for people as we know them, and more like a challenge that may require new kinds of humans, new forms of society, or new definitions of survival itself. That may sound severe, but there is also gentleness in it. It reminds us that there is nothing small or trivial about being a creature of one world. To belong to Earth is not a weakness. It is a deep biological truth. We are shaped by a planet so thoroughly that even imagining life far from it reveals how much of ourselves we owe to home. And perhaps that is worth feeling for a moment. We often speak of the stars as though they are calling us outward, as though maturity means leaving our cradle behind. But maybe another part of wisdom is recognizing what a cradle really is. Not a cage. Not an embarrassment, but a system so rich, stable, and generous that its absence reveals itself only when we try to replace it. Maybe that is why intergalactic travel feels so haunting. Not because it is merely far, but because it asks whether the human being can be separated from Earth without becoming something else. And if one lifetime is too short, if one body is too fragile, if one mind is too earthbound, then the next idea begins to arrive almost by necessity. Perhaps the journey would not belong to one crew at all. Perhaps it would belong to many generations, one after another, living and dying aboard the same moving world, each inheriting the mission without ever seeing its beginning. And that is where the dream becomes stranger still. Because once we accept that ordinary human lives may not survive the full journey, the ship stops looking like transportation. It starts looking like a civilization in motion. Part 7. Could generation ships ever solve it? Once you accept that one human life is too short for the journey, a new idea appears almost automatically. Do not send one lifetime. Send many. At first, that idea feels almost elegant. If the distance to another galaxy is too great for any ordinary crew to survive from departure to arrival, then perhaps the solution is not to make the people last longer, but to let the mission outlive them. One generation begins the journey. Their children inherit it. Then their children after them. And so, slowly, across centuries or perhaps far longer, the ship continues forward, carrying a chain of human lives across the dark. It is one of the oldest and most haunting answers to the problem of deep space travel. Not faster ships. Not immortal people, but a civilization in motion. And there is something deeply human about that idea. Human beings have always built things they would never personally finish. Temples, cathedrals, cities, traditions, languages, nations, libraries, orchards, family names. We plant for people we will never meet. We repair what our ancestors left behind. We inherit more than we create, and we pass on more than we fully understand. In that sense, a generation ship does not feel unnatural at all. It feels like a cosmic extension of something very old. A long promise carried by people who know they will never see its completion. And yet, once you sit with the idea quietly, it starts to change. Because a generation ship does solve one problem, but it also creates many others, and some of them may be just as difficult as the distance itself. If these quiet explorations help you relax, you can always leave a like, subscribe, or share a thought in the comments later on. I always enjoy hearing which ideas feel hopeful, and which ones feel quietly unsettling, once you spend time with them. The basic logic of a generation ship is simple. If the journey to another galaxy cannot fit inside a single lifespan, then the ship itself must become more than transportation. It must become a place where life can continue normally enough for new generations to be born, raised, educated, and prepared to keep the mission alive. It would not be a crew in the usual sense. It would be a small society, a moving world, a sealed human continuity project drifting between the galaxies. And if you phrase it that way, it almost sounds possible. Not easy, not near, but conceptually possible. Because after all, human beings do know how to build societies. We know how to raise children. We know how to grow food, preserve knowledge, teach skills, manage conflict, repair systems, maintain purpose, and survive hard conditions when the alternative is collapse. In some ways, a generation ship seems more realistic than many other intergalactic dreams, precisely because it does not try to cheat time. It accepts time. It does not ask the universe for mercy. It simply tries to carry life forward within the rules we already know. That honesty is part of why the idea has such power. It feels less like science fiction magic, and more like a difficult extension of ordinary human endurance. But this is also where the gentler version of the dream ends. Because a generation ship is not just a ship with a lot of people on it. It is a place where most of the people aboard would not have chosen the mission in the first place. That one fact changes everything. The first generation might volunteer. They might train for years, understand the stakes, embrace the sacrifice, and step aboard with a clear sense of purpose. They would know what they are leaving behind, and at least emotionally, they could tell themselves they chose it. Their children could not. The children born aboard the ship would not be explorers in the same sense. They would be natives of an artificial world. They would open their eyes inside metal walls, managed air, controlled light, careful routines, and a mission that began before they existed. Home, for them, would not be Earth. Home would be the ship. And that is a profound shift. Because once the ship becomes home, the journey changes meaning. It is no longer simply a passage toward a destination. It becomes an inherited condition of life. A person born aboard does not feel like a traveler waiting to arrive. They feel like a resident of the only world they have ever known. This is where the idea becomes less technological and more philosophical. What exactly would arrival mean to someone who never left? Imagine being born on such a vessel. You grow up hearing stories of Earth, perhaps of the Milky Way, perhaps of the mission itself. You are taught that your world is moving through darkness toward a place your ancestors chose long ago. You learn maintenance, agriculture, navigation basics, social responsibilities, history, maybe even astronomy, though the stars outside have changed so slowly over generations that the movement itself feels abstract. Would you experience the journey as noble? Or would it feel like an old burden wrapped in sacred language? That question matters because generation ships depend on continuity of purpose. The mission only works if people many generations later still care enough to preserve systems, teach knowledge, accept limits, and cooperate with a destination they will never personally benefit from. And that is not a small assumption. Human societies on Earth struggled to maintain shared purpose across a few decades, even with a full planet beneath them, fresh horizons, and the possibility of migration, trade, reinvention, or escape. A sealed interstellar or intergalactic society would not have those outlets. Its members would inherit not only a mission, but also confinement, resource limits, social obligation, and the heavy knowledge that every failure has nowhere else to go. That is one of the first deep problems with generation ships. They may solve lifespan by replacing individuals with lineage, but they do not solve motivation. In fact, they may make motivation harder, because the farther the ship travels, the more the original dream belongs to the dead. There is something almost quietly tragic about that. The people who believed most deeply in the mission would not be there at the end, and the people at the end might not feel the mission in the same way at all. This is why a generation ship cannot simply be engineered like a machine. It must also be engineered like a culture. It would need stories strong enough to survive centuries, institutions flexible enough to adapt, but stable enough not to collapse, education clear enough to preserve technical knowledge without allowing it to become empty ritual, leadership strong enough to resolve conflict, but legitimate enough not to turn the ship into a prison. And perhaps most difficult of all, it would need a way to make inherited duty feel meaningful to people who never consented to it. That last part is ethically difficult, because a generation ship is, in a real sense, a decision made by one group of humans on behalf of other humans who do not yet exist. That is not unusual in small ways. Parents make choices that shape the lives of children all the time. Societies pass on debt, culture, infrastructure, pollution, education systems, and political realities to later generations constantly. We are always born into unfinished human decisions. But a generation ship intensifies that pattern to an almost unbearable degree. A child born aboard such a ship would not simply inherit a country, or a school system, or a family story. They would inherit the entire physical condition of their existence. Their sky, their food, their options, their social world, and perhaps the central meaning of their life would all be determined by a mission launched centuries earlier. That begins to feel less like travel and more like destiny imposed by architecture. Some people might accept it peacefully. Some might embrace it with genuine pride. Human beings are good at finding meaning inside inherited structure. But others might resist it. They might ask very direct questions. Why should I dedicate my life to a destination I did not choose? Why is arrival more important than the life I already have here? If the ship is my home, why should I risk it for the sake of a promise made by strangers in the distant past? There are no easy answers to those questions. And because there are no easy answers, a generation ship must assume one of two things. Either the society aboard remains remarkably healthy, reflective, and cooperative across deep time, or it develops stronger tools of control to keep everyone aligned. Neither option is simple. A very healthy ship society might preserve purpose through education, shared identity, fairness, meaningful work, and a culture that genuinely values continuation. But maintaining that across long spans may be one of the most difficult social challenges imaginable. The ship would be closed, resources limited, personal freedom constrained by system needs. Minor conflicts might matter a great deal. A single bad generation of leadership could damage institutions that took centuries to build. The other option, stronger control, carries its own dangers. A mission-focused society might become rigid, hierarchical, punitive, obsessed with duty. It might preserve the journey at the expense of the people living it. And in that case, the generation ship stops feeling like a brave human answer to the stars and starts feeling like something colder. A civilization trapped inside its own objective. That is why generation ships are such strange objects in thought. They are both practical and unsettling. They accept reality better than fantasies of instant travel. Yet they also force us to confront a difficult truth. Sometimes the most realistic solution is the one that changes the human meaning of the mission the most. There are also practical biological questions. A generation ship would need not just a stable population, but a healthy one. That means enough genetic diversity to avoid severe long-term problems. It means reproductive health across generations in an artificial environment. It means childhood development, education, healthcare, aging, and death all taking place within a closed system. On Earth, these processes unfold in the open richness of a planet. On a ship, they would unfold inside a managed environment where every resource loop matters. Water must be recycled. Air must remain breathable. Food systems must stay productive. Waste must be processed. Disease must be contained. Medical knowledge must be preserved. Mental health must be supported. And all of this must happen not for a month, or a year, or even a century, but long enough for many generations to pass without any catastrophic break in continuity. This is where the ship begins to resemble not a vehicle, but a tiny artificial biosphere. And biospheres are delicate. Even on Earth, where life has immense redundancy and room to recover, ecosystems can become unstable. In a closed environment, that fragility becomes sharper. A crop disease, a water contamination event, a failure in atmospheric processing, a breakdown in maintenance culture, or a slow unnoticed shift in one biological system could become existential over time. The longer the mission lasts, the more likely rare failures become. And rare failures are exactly what deep time produces. This is one of the quiet laws of long duration. If something can go wrong, then over enough centuries, it may not remain an exception. It may become a probability waiting for its turn. That is why generation ships are not simply about surviving year by year. They are about surviving cumulative reality. Small mistakes can accumulate. Knowledge can erode. Materials can fatigue. Traditions can drift. Institutions can harden or decay. The ship must not only remain alive, it must remain intelligently alive. That distinction matters. A society can survive while becoming less capable. It can continue while losing critical understanding. It can preserve rituals long after it forgets their original purpose. And perhaps nothing captures the vulnerability of a generation ship better than that possibility. Imagine a ship centuries into its journey. The descendants of the original crew still perform maintenance tasks, still observe routines, still repeat core teachings about the mission. But perhaps some knowledge has thinned. Some systems are less understood than they once were. Some procedures have become ceremonial rather than scientific. A few areas of the ship are no longer fully accessible. Repairs become more cautious, then more superstitious. The destination survives in memory, but now as half history, half belief. That may sound dramatic, but it is not impossible. Human knowledge is always more fragile than it looks. Entire techniques have been lost on Earth despite writing, trade, cultural exchange, and vast populations. Imagine preserving an advanced technical civilization inside one sealed structure, across centuries, with no outside correction, no imports, no new universities beyond what the ship itself can maintain, and no margin for total failure. The more honestly we picture it, the more the challenge feels civilizational, not mechanical. And then there is boredom. It sounds like a small word for such a grand subject, but boredom may matter more than it first appears. Human beings do not thrive on repetition alone. We need novelty, horizons, projects, art, humor, beauty, surprise, and the possibility of lives that feel larger than maintenance. A generation ship society built only around efficiency might remain technically functional for a while, but over time it could become psychologically thin. So a real generation ship would need more than air and food. It would need culture, music, games, stories, education that is not only useful, but enriching. Ways to love life aboard the ship, not merely endure it. In other words, it would need to be more than a survival machine. It would need to be a home worth inheriting. This may be one of the strongest arguments in favor of the concept, oddly enough. If a generation ship ever could work, it would probably work not because it turned people into perfect mission followers, but because it succeeded in becoming a genuine world. A place where ordinary life felt possible, where children could laugh, where people could fall in love, where seasons might be simulated, where art could exist alongside agriculture, where maintenance and meaning were not enemies. The ship would have to become not a waiting room for another galaxy, but a complete society in its own right. And once you say that clearly, another thought follows. If the ship becomes a complete society, then perhaps arrival matters less than we once assumed. That is a strange twist, but an important one. The better the generation ship works as a world, the less its people may feel incomplete without the destination. If life aboard is rich enough, then the ship is not merely traveling through history. It is making history. Its people are not placeholders. They are a civilization. And civilizations do not always remain emotionally loyal to the dreams of their founders. This means success creates its own paradox. If the ship is too harsh, people may resist the mission. If the ship is too livable, people may stop caring whether the mission ends. A society that truly flourishes aboard may eventually ask whether arrival is worth the risks that arrival would bring. Why leave a functioning world for an uncertain one? Why trade a known environment for a planet or system none of the living have ever seen? Why continue pushing toward an old target rather than simply preserving the ship as home? This is not a side issue. It may be one of the central questions of all long-duration travel. Because once a moving civilization becomes stable enough to survive, it may also become stable enough to choose differently. And that means the original mission must survive not only hardship, but prosperity. There is another quiet difficulty here as well. Time changes values. Human beings do not think exactly as their ancestors did, even across a few centuries on Earth. Our moral ideas shift. Our social structures shift. Our technologies, fears, and hopes change. So what would happen across 10 generations? 20? 50? The descendants aboard the ship may not even share the original founders' understanding of what a good life is. Maybe they would become more collective, because survival requires it. Maybe more individual, because confined life creates hunger for freedom. Maybe more spiritual, more scientific, more ritualized, more artistic, more hierarchical, more democratic, or something stranger than any of those. Whatever they become, they would not be frozen in the intentions of the launch generation. They would be living humans shaped by their own world. And their world would be the ship. So could generation ships solve the problem of going beyond our galaxy? In one narrow and important sense, yes. They are among the few concepts that take the real timescale seriously without relying on impossible speed, suspended magic, or instant shortcuts through physics. A generation ship accepts that the journey may outlast anyone who begins it, and it answers by turning the mission into inheritance. That makes it, in some ways, one of the most sober and honest ideas in all of deep space thinking. But honesty is not the same as ease. Generation ships do not erase the challenge. They relocate it. The problem stops being how one crew survives the distance, and becomes how an entire civilization survives continuity. How it preserves knowledge, fairness, health, purpose, reproduction, maintenance, culture, and consent inside a closed world moving through near-perfect emptiness. How it stays alive materially, but also alive morally and psychologically. How it remains human without becoming trapped by either despair or rigid duty. And maybe the deepest difficulty of all is this. A generation ship can cross time, but can it cross meaning? Can a mission chosen by the dead still feel alive to the living? Can a society born in transit remain loyal to a destination it has never seen? Can home remain a destination ahead, rather than the ship itself? Those are not engineering questions, though engineering matters. They are questions about human nature under pressure. Questions about inheritance, identity, and the fragile continuity of purpose across deep time. And that is why generation ships feel both plausible and heartbreaking. They may be the closest thing to a real answer we have, yet they solve the journey only by transforming it into something far stranger than ordinary travel. The ship becomes a world. The crew becomes a people. The mission becomes a civilization's memory of why it is still moving. And once a civilization is moving through darkness for long enough, another challenge slowly grows in importance. Not just staying alive, not just staying loyal, but staying on course. Because over immense spans of time, even tiny errors can become enormous. A small drift in direction, a slow breakdown in navigation, a damaged sensor, a forgotten correction, or a subtle failure in maintenance could matter more than anyone aboard fully realizes until it is far too late. And in the silence between galaxies, where there are few landmarks and even progress can feel invisible, that kind of drift may become one of the most frightening problems of all. Part 8: The problem of staying on course through deep time. Once a journey becomes long enough, distance stops being the only thing that matters. Direction begins to matter just as much. That may sound obvious at first. Of course, direction matters. If you are trying to reach another galaxy, you have to aim correctly. But on ordinary human journeys, direction feels manageable. A road bends, and you follow it. A plane adjusts its heading. A ship corrects for wind and current. Even when the trip is difficult, the idea of staying on course still belongs to the familiar world of maps, instruments, and small corrections made over hours or days. Deep time changes that. Because when a journey lasts not days, not years, but generations, direction becomes something stranger. It is no longer just a matter of steering well in the moment. It becomes a matter of preserving accuracy across centuries, perhaps millennia, perhaps longer than any human institution has ever survived intact. And that is where the question turns quietly severe. Not can you begin the journey, not even can you survive it, but can you keep moving toward the same destination, with enough precision, for a span of time so long that the people doing the navigating may not even remember the original departure as anything more than inherited story. If these quiet walks through science help you rest a little easier, you can always leave a like, subscribe, or tell me in the comments what part of the universe feels most mysterious to you. I always enjoy seeing which ideas stay with people once the room gets quiet. The first thing to understand is that space does not come with road markings. There are no painted lines between galaxies. No signs suspended in the dark saying keep straight for 2 million more light years. No cosmic channel worn into the void by earlier travelers. Space is mostly emptiness, and emptiness can be deceptive. It feels simple because there is so little in it. But simplicity is not the same as guidance. On Earth, if you drift a little off course, the world usually tells you. A coastline appears where it should not. The sun sits in the wrong place. Landmarks no longer line up. A compass, a star, a radio signal, a satellite, a map, a road, all of these can help pull you back. Between galaxies, those comforts thin away. And the longer the journey, the more a very small error can grow into something enormous. This is one of those truths that feels mild when spoken and frightening when felt. A tiny mistake at the beginning of a short trip is usually harmless. A tiny mistake at the beginning of a very long trip may not look like a mistake at all for a very long time. That is what makes it dangerous. If you are aiming at something unimaginably far away, even a slight deviation in angle can turn into a miss so large that no ordinary correction later can fully repair it without paying a heavy price in time and energy. The farther the distance, the more cruelly small errors are magnified. It is like shining a flashlight across a room versus across a continent. A tiny tilt of the hand barely matters in the room. Across a vast distance, it can move the beam by miles. On an intergalactic scale, the same logic becomes almost impossible to emotionally grasp. And a ship does not make only one steering decision. It makes countless ones. Some are deliberate, small course corrections, carefully measured and executed. Others are imposed from outside. Tiny gravitational influences, subtle interactions with particles, mechanical imperfections, sensor drift, software decay, damage from radiation, wear in moving parts, misread data. human misunderstanding, cultural erosion of technical knowledge, small neglected maintenance tasks that become slightly larger ones later on. None of these need to be dramatic to matter. Deep time does the drama for them. That may be one of the hardest things for the human mind to accept. We are used to fearing large failures, explosions, catastrophes, sudden impacts. But long journeys are often threatened less by one large disaster than by the patient accumulation of smaller ones. A system that is 999% reliable sounds wonderful until you ask it to remain reliable across centuries of continuous use. Then the tiny gap hidden in that percentage starts to become a living concern. And navigation is made of systems. Sensors must remain accurate. Clocks must remain consistent. Star maps must stay interpretable. Computers must keep calculating. Mechanical components must still respond to control. Power must remain available. Knowledge must remain teachable. Corrections must still be possible when needed. Each piece may work beautifully in the beginning. The problem is not the beginning. The problem is duration. The longer the ship is alive, the longer it has to be right. That is a very different demand. It helps to remember that even here, in the relatively forgiving neighborhood of Earth, precision navigation is not trivial. Space agencies spend enormous effort tracking and correcting the trajectories of their probes. Missions to planets, moons, asteroids, and comets are often won or lost through careful adjustments made over long periods. A tiny burn at the right time can bring a spacecraft safely to its target. A tiny error, left alone, can grow. And those are missions measured in years, maybe decades, with a civilization behind them. Engineers, computers, observation networks, updated models, and constant human attention all help keep the craft honest. Now imagine a ship with no home-based guidance, no immediate support, no real-time conversation with mission control, no quick replacement of faulty sensors, no easy external recalibration against a fresh wave of experts. Only the ship, its people or systems, and the dark. At that point, staying on course is no longer a task. It becomes a culture. The ship must not only know how to navigate, it must remember how to care about navigation across generations. That is a more difficult thing than it may sound. Because navigation is not emotionally vivid most of the time. It is maintenance of alignment, verification, repetition, quiet attention to small discrepancies. The kind of work that is easy to neglect precisely because nothing dramatic happens when it is done well. A society aboard a long-duration vessel would need to preserve respect for things that do not reward the senses. Numbers, checklists, calibration routines, abstract models of position and motion. A future-oriented discipline sustained without the help of immediate visible progress. That is a tall order for any civilization. On Earth, humans often maintain discipline by attaching it to visible outcome. Farmers see crops grow. Builders see walls rise. Sailors see the coast approach. But on a ship crossing vast darkness, navigation may offer almost no emotional feedback. The stars might shift too slowly to comfort an individual life. The destination may remain a distant abstraction. If a correction is made properly, the reward may be nothing more than the continued absence of disaster. And absence is not always easy to build a culture around. This means that the problem of staying on course is partly physical, but also deeply psychological. How do you teach generations of people to respect invisible drift? How do you convince them that tiny errors matter when those errors do not yet feel like danger? How do you sustain reverence for precision in a world where the consequence of imprecision may take centuries to reveal itself? That is not only a navigation problem, it is a civilization problem. And if the ship depends more on automation than on human judgment, the problem changes shape but does not disappear. Because then the question becomes whether machines can maintain trustworthy guidance across deep time. At first, that sounds easier. Machines do not get bored. They do not argue. They do not forget the mission because they had a difficult childhood or lost faith in their ancestors. A sufficiently advanced system might monitor position continuously, compare internal models with observed reality, and apply corrections with a patience no human crew could ever match. Perhaps. But machines are not magic either. Hardware degrades. Sensors age. Memory can be corrupted. Radiation can flip bits. Software can behave unpredictably under strange conditions or after long accumulation of edge cases. A maintenance culture must still exist to understand what the automation is doing, verify that it is still reliable, and step in when the machine begins quietly drifting in ways no one notices at first. This is one of the strangest aspects of very long journeys. Automation may be necessary, yet over-reliance on automation may also become a hidden danger. If generations grow used to systems that simply work, they may lose the depth of understanding needed to repair or challenge those systems when something subtle goes wrong. Human history contains many smaller versions of this lesson. People can become skilled at operating a tool without understanding its deeper principles. Traditions remain intact while the reasoning behind them fades. Knowledge that once lived close to the hands and mind becomes narrower, more procedural, more fragile. On a ship crossing deep time, that erosion could matter enormously. Imagine a navigation system that has functioned for centuries. It has always been trusted. It has always produced the numbers the ship expects. But gradually, perhaps through radiation damage, perhaps through imperfect repairs, perhaps through accumulated small software anomalies, its models begin to drift. Not enough to trigger alarm immediately. Just enough to remain plausible. Would the ship know? Would the people aboard still possess the kind of independent navigational literacy needed to question it? Or would the system's long history of success make it feel too sacred, too ordinary, too embedded in daily trust to examine until the error had grown large and expensive? That is the sort of danger deep time introduces. It turns trust itself into a vulnerability. There is also the question of external reference points. How does a vessel in deep space know where it is? The answer, at least in principle, involves looking outward and measuring. Stars, pulsars, perhaps distant galaxies, perhaps carefully modeled background signals. Pulsars are especially interesting here. These spinning remnants of dead stars emit regular pulses of radiation with extraordinary precision, almost like cosmic lighthouses. Some scientists have suggested they could serve as a kind of galactic navigation framework, allowing spacecraft to determine position by comparing the timing of pulses arriving from different directions. It is a beautiful idea. Quiet, elegant, and very fitting for a universe that seems indifferent until it suddenly provides a subtle tool. But even if pulsars or other celestial references help, using them over immense durations still depends on stable instruments, good models, and ongoing interpretation. The sky itself is not frozen. Stars move. The ship moves. Time changes the background. Instruments must keep seeing clearly. Systems must keep translating observation into trustworthy position. And all of that must continue through wear, cultural change, and perhaps generations who relate differently to both the mission and the mathematics beneath it. Deep time makes even beautiful solutions feel provisional. There is another quiet complication too. The destination itself is not standing still. This matters more than it first appears. When people imagine aiming for another galaxy, they often picture a target fixed in the darkness, like a bright island waiting patiently. But galaxies are moving. They have their own velocities, their own internal motion, their own relationship to expanding space and nearby structures. A destination millions of light years away is not simply sitting there unchanged while you travel toward it. You are trying to meet something that is also in motion. That means navigation is not just about pointing at where the destination is now. It is about understanding where it will be when you arrive, and arrival may happen so far in the future that your prediction becomes an argument with cosmology itself. This begins to feel less like navigation in the ordinary sense and more like forecasting reality over spans that swallow civilizations. And then there is the ship itself, not as a mathematical point, but as a physical object under stress. Micro-impacts, however sparse. Material fatigue, uneven wear, distortion from thermal cycling, gradual degradation in structural alignment. These things do not need to destroy the ship to affect navigation. They only need to change the behavior of key systems slightly. A sensor mount that shifts, a gyroscope that grows less precise, a reaction control system that fires with tiny asymmetries, a rotational imbalance in a spinning habitat, an uncorrected mass redistribution after repairs or internal redesign. Each by itself may be modest. Over enough time, modesty is not a guarantee of harmlessness. This is why staying on course is inseparable from maintenance discipline. Navigation is not only about where the ship is pointed. It is about whether the whole vessel remains a trustworthy platform for knowing and changing where it is pointed. The health of guidance systems, structure, power, data, and human knowledge all become part of the same quiet question. Are we still going where we think we are going? That may be one of the most unsettling questions a deep space civilization could ever ask. Because if the answer becomes uncertain, then many other things become uncertain with it. Resource planning, meaning, sacrifice, inherited duty. All of it depends on the belief that the motion still corresponds to the mission. Imagine, for a moment, discovering after generations that the ship has drifted far enough from its intended course that the original destination is no longer realistically reachable with the remaining reserves. The mission would not merely face a technical setback. It would face an existential one. A society built around continuation would suddenly have to ask whether continuation still has the same object. Whether the purpose that justified confinement, discipline, and sacrifice has quietly dissolved in the mathematics. That sort of revelation could be socially explosive, because staying on course is not just a matter of reaching the right place. It is also a matter of preserving the legitimacy of the journey. As long as the ship remains aligned, the mission retains coherence. But if alignment is lost, then 100 quiet decisions suddenly come back under question. Why were we conserving? Why were we obeying? Why were we accepting limitation? Why did our parents and grandparents build their lives around this? What exactly are we continuing now? A drift in navigation could become a drift in meaning. And meaning, once drifted, may be even harder to recover. This is one reason the ship might need more than technical procedures. It might need institutional humility, independent checks, multiple navigation traditions, redundancy not only in hardware, but in interpretation. Perhaps different groups trained to verify one another. Perhaps archival practices designed to preserve not only instructions, but first principles. Perhaps educational systems that keep the deeper logic alive so that future generations are not merely repeating sacred routines, but understanding why those routines matter. That sounds wise, and it is, but it is also expensive. Redundancy always costs something. More systems, more training, more energy, more social complexity. Every safeguard added to reduce navigational fragility makes the ship itself heavier in one sense or another. Again, the universe does not offer easy terms. Even philosophical drift can matter here. Over centuries, what counts as the course may not remain simple. Suppose the ship remains technically capable of continuing, but cultural priorities change. Suppose some aboard argue that the destination should be altered to a closer target, a different structure, or no target at all. Suppose the original course is still mathematically valid, but socially contested. Is staying on course then a technical obligation, or a political choice? Deep time has a way of turning even numbers into arguments. A course is never just a line in space. It is a line joined to purpose. And purpose belongs to living beings who interpret it, inherit it, revise it, or sometimes reject it. So perhaps the deeper problem is not merely that the ship might drift physically, but that it might drift civilizationally. Its position could remain precise while its understanding of why precision matters grows uncertain. Or the reverse. The mission could remain sacred while the technical competence needed to execute it slowly thins. Either kind of drift would be dangerous. Maybe that is what makes the whole idea so haunting. We often imagine long journeys as tests of strength, endurance, and patience. But staying on course through deep time may be something subtler. A test of continuity, of whether knowledge, discipline, trust, and purpose can remain aligned long enough to resist not only the void outside, but the slow, soft erosion that time performs on every system within. It is difficult not to feel a certain tenderness toward any civilization that tried. A ship moving between galaxies would not be failing or succeeding in some dramatic instant. It would be waking each day, if days still meant anything aboard, and quietly reconfirming itself. Rereading the sky. Rechecking the numbers. Verifying the instruments. Correcting the line. Teaching the young what matters. Preserving attention against boredom. Preserving humility against complacency. Preserving purpose against drift. That is a very gentle sort of heroism. Not the heroism of explosions and bold speeches. The heroism of continued accuracy. The heroism of not letting the invisible become neglected just because it is invisible. And still, even if a ship somehow mastered all of this, even if it survived the biological burden, the energy burden, the social burden, and the navigational burden, there would remain one more quiet complication waiting in the background. The universe itself is not a fixed stage. Space is expanding. The distance to a faraway galaxy is not simply a number written once and preserved forever. The cosmos changes while you travel. The destination moves. The gulf stretches. In some cases, the finish line may not just be distant. It may be retreating. And once that begins to settle into view, the whole question changes again. Because then the challenge is no longer only whether you can survive the journey and stay on course. It becomes whether the journey can ever truly catch up at all. Part 9. The universe is expanding while we travel. There is one final comfort people often keep, even after accepting how large the galaxy is, how empty the space between galaxies is, how slow we are compared with cosmic distance, and how fragile any long journey would become. The comfort is this: at least the destination is waiting. At least if a ship could somehow survive long enough, if it could move fast enough, if it could carry life, energy, memory, and purpose across the dark, then the faraway galaxy would still be there ahead like a fixed shore. Distant, yes. Difficult, certainly. But still present in the ordinary way a destination is present. A place that simply waits for the traveler to arrive. And that is where the universe adds one more quiet complication. Because on the largest scales, the cosmos is not standing still while we move through it. It is changing. Space itself is expanding. And that means the journey beyond our galaxy is not just a matter of crossing a fixed gap. In many cases, the gap is stretching while you try to cross it. The destination is not always sitting patiently in the dark. Sometimes it is drifting. Sometimes it is receding. And sometimes, if the distance is great enough, it may be slipping away in a deeper sense than ordinary motion can easily overcome. This is one of those ideas that sounds almost abstract the first time you hear it. The universe is expanding. Most people have heard some version of that sentence before. It belongs to the background of modern cosmology now, almost like a fact we keep on a shelf because it seems too large to affect daily life. But when you bring it into the story of a real journey, it changes everything. Because once the universe itself begins to move under your feet, the meaning of distance becomes stranger than it first appears. If these slow explorations help you relax, you can always leave a like, subscribe, or share a thought in the comments later on. I always enjoy seeing which part of the universe lingers longest in people's minds after the room gets quiet. A useful place to begin is with a very gentle correction. When people imagine the universe expanding, they often picture galaxies flying outward through empty space, as though some ancient explosion threw them away from one central point. That image is understandable, but it is not quite right. The more accurate picture is not that galaxies are racing through pre-existing space like sparks from a fire. It is that space itself is stretching, and the galaxies are being carried along with that stretching. This difference matters. Imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves farther away from every other dot. None of the dots needs to crawl across the rubber. The surface itself is expanding, and the distance between the dots increases because the background grows. That analogy is not perfect, but it helps. The universe is not expanding into some empty room outside itself. Rather, the distances within it are increasing on large scales. Space is not a passive stage. It participates in the story. And once you begin to feel that, you realize something important. A traveler moving through expanding space is not crossing a still ocean. They are crossing water that is slowly widening beneath them. That widening is not equally important everywhere. This is another detail that makes the universe beautifully strange. On small scales, gravity can overpower the cosmic expansion. Solar systems do not get torn apart by the expansion of the universe. Galaxies do not generally swell and dissolve because of it. Even groups of nearby galaxies can remain gravitationally bound. The local strength of gravity can hold systems together against the broader tendency of space to stretch. That is why Earth remains comfortably near the Sun, and why the Milky Way itself has not been quietly unraveling while we sleep. So the expansion of the universe is not something you notice in your backyard, or even across a galaxy in the way you might first expect. It becomes important across truly immense distances, where the weak but persistent tendency of space to stretch can dominate over gravitational bonds. And that is precisely why it matters to the question of leaving our galaxy. Because the moment you begin aiming not merely at another star or another region of the Milky Way, but at another galaxy or another cosmic structure beyond our local neighborhood, you are entering the realm where expansion can no longer be treated as a background curiosity. It becomes part of the journey itself. The nearest major galaxy to our own is Andromeda, and Andromeda is often the first destination people imagine when they think about intergalactic travel. It seems like the obvious next step. Our large neighboring island of stars. Distant, but not absurdly remote by cosmic standards. The first grand shore beyond our own. And here the universe does something unexpected. Andromeda is not receding from us. It is actually moving toward us. That sounds like a contradiction until you remember the earlier point. Cosmic expansion is real, but local gravity can overpower it. The Milky Way and Andromeda both belong to the same small galactic neighborhood, called the local group. Gravity within that group is strong enough that Andromeda is not being carried away from us by the expansion. Instead, the two galaxies are drawing toward each other and are expected, over billions of years, to eventually merge. That detail is important because it keeps us honest. The universe is not expanding in some simple, uniform way that makes every object race away from every other object under all circumstances. Reality is more textured than that. Some places are bound together. Some are not. Some destinations remain available, at least in principle. Others slowly drift beyond reasonable reach. This means the question is not merely, is the universe expanding? It is, at what scale does that expansion begin to defeat the local grip of gravity? And once the answer moves beyond the local group, the picture changes again. Farther galaxies are, in general, moving away from us. Not because they chose a direction, not because some center of the universe is pushing them outward from one point, but because the fabric of space between large structures keeps stretching. The farther away a distant galaxy is, the more space lies between us and it, and the more total expansion can accumulate across that space. This leads to one of the strangest rules in cosmology. The farther away a galaxy is, the faster it appears to recede. That sentence sounds simple. Its emotional meaning is not, because it means distance is not merely a passive fact. Distance itself can create more recession. The larger the gulf, the more room there is for the universe to continue widening it. So now imagine a ship leaving the Milky Way and heading outward across the dark. At first, perhaps the destination remains clear. The ship has a heading. It has a model of where the target is, where it is going, and how long the trip may take. But all the while, the underlying geometry of the universe is continuing its own slow work. The space between the ship and the faraway target is not just sitting there. It is participating in the cosmos. It is stretching. That does not necessarily mean the ship can never arrive. Not immediately. But it does mean the traveler is involved in a more subtle race than ordinary intuition suggests. You are not simply moving toward the destination. You are moving toward a destination while the structure of the gap itself keeps evolving. This is where the old human metaphor of a voyage begins to strain. On Earth, if you walk toward a mountain, the land between you and the mountain does not usually create more land while you walk. If you sail toward an island, the sea does not slowly manufacture new sea beneath your ship in a way that meaningfully changes the trip. But on cosmological scales, something like that does happen. The medium is not inert. Space participates. And that can make the finish line feel stranger than almost any ordinary journey ever asks it to feel. There is also another detail here, one that is almost quiet enough to be missed. The expansion of the universe is not merely continuing. It is accelerating. This was one of the great shocks of late 20th century cosmology. For a long time, many scientists expected that the expansion, though real, might be slowing over time under the pull of gravity. After all, matter attracts matter. The universe contains galaxies, gas, stars, clusters, dark matter, and all of that mass pulls gravitationally. It was natural to wonder whether the cosmic expansion might gradually weaken. Instead, observations suggested something stranger. The large-scale expansion is accelerating. Some mysterious influence, often called dark energy, seems to be causing space itself to stretch faster over time on the largest scales. We still do not know exactly what dark energy is. The name is more a marker of ignorance than understanding. But whatever it is, the consequence is severe. On cosmic scales, the widening of the universe is not a temporary event running out of steam. It appears to be an ongoing, even strengthening feature of reality. And this changes the emotional tone of the journey once again. It means the universe is not only wide, it is becoming wider in a specific and growing way. A traveler trying to cross intergalactic distances is not merely challenging a fixed architecture. They are traveling inside an architecture whose large-scale separations are actively evolving. For nearby structures like Andromeda, gravity still dominates the relationship. But beyond certain distances, the story becomes colder. Galaxies farther out are not just far away. They are being carried away by the expansion strongly enough that catching them becomes increasingly implausible. At some point, this idea becomes so severe that it creates what we often call a cosmic horizon. There are regions of the universe so distant, and receding in such a way, that light emitted from them now may never reach us in the future. Not because light is slow in any ordinary sense, but because the expanding geometry between us and those regions defeats the journey of that light. The gulf wins. That is an astonishing thought. It means parts of the universe exist that are real, but not reachable in any practical or perhaps even theoretical sense through ordinary motion and communication. Not hidden by darkness. Hidden by the expansion of spacetime itself. The universe, in other words, contains its own form of permanent separation. And if that is true for light, which moves at the fastest speed nature allows, then it is even more severe for any ship carrying matter, machinery, and life. A human vessel would not merely be slower than light. It would be trying to cross an expanding gulf with all the burden of mass, shielding, maintenance, navigation, and survival already attached to it. So when we ask whether humanity could ever leave the Milky Way and reach some faraway galaxy, we are no longer asking a single question. We are asking several at once. Can the ship survive? Can it move fast enough? Can it preserve life and meaning? Can it stay on course? And is the target even remaining available in the long sense that availability would require? This last question is the one expansion places before us. Not all destinations remain equally open forever. Some are, cosmologically speaking, drifting toward irrelevance for us. Not because they vanish in a magical way, but because the structural widening between us and them continues to deepen their separation. It is a little like standing on one shore while another shore slowly slides away, not through the water, but because the sea itself keeps widening between them. There is something almost heartbreaking about that image, because it means the universe is not simply hard to cross. It is, in a certain sense, becoming harder. And that has a subtle consequence for the dream of exploration. It means that time is not neutral. Waiting is not just delay. On very large scales, waiting can alter what is still reachable. The cosmic map is not merely large, it is dynamic. What is in principle accessible during one era of the universe may not remain equally accessible forever. That does not mean our immediate cosmic neighborhood is slipping away tomorrow. The timescales here are immense, far beyond daily human concern. But this is exactly why the idea matters so much in the context of intergalactic travel. A mission ambitious enough to aim beyond the Milky Way already commits itself to durations where such slow cosmic changes become part of the meaning of the trip. If your journey lasts millions of years, then the long-term behavior of spacetime itself is no longer a background note. It is part of the route. This may be one of the deepest reasons intergalactic travel feels so fundamentally different from all smaller kinds of exploration. To cross a continent, you negotiate weather. To cross an ocean, you negotiate currents and storms. To cross the solar system, you negotiate distance, gravity, and energy. But to cross between galaxies, you may also be negotiating cosmology. The large-scale behavior of the universe enters the practical story. That is almost an absurdly large thing to ask of a journey. And yet it is true. There is another quiet emotional shift that comes with this. Expansion changes the meaning of home, as well as destination. We often imagine ourselves located in some stable cosmic arrangement, with other galaxies arranged around us like fixed neighboring lights in a dark city. But the real universe is more like a vast and changing archipelago in which the islands of matter participate in a long, evolving separation. Home is not sitting in a still frame. Home itself belongs to this broader motion. So the traveler does not leave a fixed world for another fixed world. They travel within a moving cosmos whose deeper geometry has never promised permanence of relation. That can sound bleak, but there is beauty in it too. It reminds us that the universe is not a museum. It is not frozen for our convenience. It is alive with process, structure, transformation, and scale far beyond our native habits of thought. The very fact that the cosmos expands is part of why galaxies formed, why time has direction, why there is a story at all. We are not standing in a finished structure. We are living inside an unfolding one. Still, unfolding does not mean welcoming. The expansion of the universe may be majestic from the standpoint of understanding, but from the standpoint of travel, it is unforgiving. It turns some possible journeys into less possible ones. It stretches the already overwhelming. It introduces another quiet asymmetry between desire and reality. We may wish to go outward, but the outward itself is changing while we decide. And perhaps that is why this part of the story feels so haunting. Up to this point, many of the barriers to leaving our galaxy can still be framed as barriers of strength, knowledge, engineering, or endurance. Hard barriers, yes. Maybe even impossible ones. But still the kind of barriers that allow the proud human instinct to say, perhaps someday. Perhaps with enough growth, enough power, enough patience. Expansion adds a different tone. It suggests that some limits are not simply about whether we are strong enough. They are about whether the architecture of reality remains open to the kind of crossing we imagine. Sometimes the answer may be yes, within our local neighborhood. Sometimes no, or no longer, beyond it. There is humility in that. It means the universe does not merely ask whether we can travel. It also asks where reality still permits relationship to continue across distance at all. That is a very large question, and perhaps a strangely tender one too, because it reminds us that not all separation is caused by weakness. Some separation belongs to the way the cosmos itself becomes what it is. A galaxy may move beyond practical reach not because the traveler failed, but because the universe never promised that every light would remain part of the same accessible world forever. And if you let that settle for a moment, the dream of leaving the Milky Way changes again. It no longer feels like just a difficult engineering project. It feels like an argument with cosmic history. Not only must the ship outlast bodies, cultures, systems, and errors. It must also travel inside a universe whose great distances are not passively waiting to be crossed. The dark itself is stretching. The map itself is changing. The relationship between here and there is not fixed. So by the time we gather all of this together, the conclusion begins to form with a kind of quiet inevitability. The journey beyond our galaxy is challenged by scale, then by emptiness, then by speed, then by energy, then by the fragility of the human body and mind, then by the difficulty of passing a mission through generations, then by the danger of drifting off course through deep time, and now, finally, by the fact that the universe itself does not stand still while we attempt the crossing. At that point, a final question begins to emerge. Not whether the journey is difficult, not even whether it is nearly impossible, but whether the journey, in the deepest sense, might never truly be completed at all. Because if the traveler changes, the mission changes, the ship changes, the meaning changes, and the universe changes while the voyage goes on, then what exactly would completion mean by the end? And that may be the quietest and most difficult thought of all. Part 10. Why the journey might never truly be completed. By the time you reach this point in the story, something has already changed. At the beginning, the dream felt clear enough. Humanity looks up at the night sky, feels the size of the Milky Way, then lets its imagination move one step farther. Beyond our own galaxy, there are others. Vast islands of stars, suspended in the deep. And once that picture appears in the mind, a simple question follows almost automatically. Could we ever go there? At first, it sounds like a question about courage, or technology, or patience. It feels like the sort of question that belongs to the future. A question with difficulty in it, certainly, but also possibility. The kind of question human beings like to ask when they want to believe that every horizon is eventually negotiable. But slowly, piece by piece, the shape of the problem has changed. The Milky Way turned out to be far larger than instinct can hold. The space between galaxies turned out to be emptier than ordinary imagination likes to admit. Speed revealed itself not as a simple tool, but as a hard negotiation with the deepest rules of physics. Energy became not just fuel, but a long and exhausting cost attached to every step of survival. The human body and mind began to look less like heroic passengers and more like delicate Earth-born systems that may not travel well across extreme duration. Generation ships offered one answer, but only by turning a journey into a civilization. Staying on course through deep time became its own quiet struggle. And then the universe itself stepped in, reminding us that space is expanding while we travel. So now, at the end of all that, a different question begins to emerge. Not whether the journey would be difficult, not even whether it would be nearly impossible, but whether the journey, in the deepest sense, could ever still count as one completed thing by the time it was over. That sounds like a strange question at first. Of course, a journey can be completed. You leave one place, you arrive at another. That is what completion means. But that definition belongs to ordinary life. It belongs to beings who live on stable land, travel across manageable distances, and remain recognizably the same people between departure and arrival. It belongs to a world where the destination does not drift too far, where the traveler can still remember the beginning, and where the meaning of getting there survives the trip intact. A journey beyond our galaxy may not grant us any of those comforts. And perhaps that is the quiet truth waiting underneath everything else. The challenge is not only that the distance is too great, it is that the distance is great enough to dissolve the ordinary meaning of completion itself. If these slow journeys through science help you relax a little, you can always leave a like, subscribe, or share a thought in the comments later on. I always enjoy hearing which ideas stay with people after the room gets quiet, especially the ones that begin as simple questions and end somewhere stranger. A useful place to begin is with the simplest image of completion we know. You go somewhere, and you arrive. The person who arrives is still meaningfully the person who left. They remember why they began. They can say, with honesty, I made the trip. Even if they changed along the way, the line remains continuous enough for the mind to accept it. That is how ordinary journeys work. But imagine a mission to another galaxy that lasts longer than any one human life. Perhaps much longer. Perhaps so long that the original crew dies, their children inherit the voyage, then their grandchildren after them, and the ship becomes a moving society. By the time arrival finally comes, no one aboard remembers Earth firsthand. No one has seen the Milky Way as home. No one can emotionally compare departure and destination because departure survives only as history. In that case, who exactly completed the journey? The founders did not. They began it. The descendants did not choose it. They inherited it. The ship arrived, perhaps. A lineage arrived. A project arrived. But did the journey remain one coherent human act from start to finish, or did it become something more fragmented than that? This is not a trick question. It matters because the word completion carries a hidden emotional assumption. It assumes continuity of subject. The one who sets out is, in some meaningful way, the one who finishes. But if a galaxy-crossing mission lasts long enough, that continuity begins to thin. The start belongs to one world. The end belongs to another. The people at the end may speak differently, think differently, believe differently, perhaps even biologically differ from those who began. The mission may survive on paper, in ritual, in education, in archives. But the emotional thread that makes a journey feel like one lived whole by a person or even a people may become increasingly difficult to preserve. And that alone begins to trouble the idea of completion. There is another complication too. Destinations change. We often speak of another galaxy as though it were a static place waiting in the dark, but that is not really how the universe behaves. Galaxies move. Stars move within galaxies. Gas clouds shift. New stars are born, old ones die. Black holes feed. Gravitational structures evolve. On the longest scales, even the broad cosmic background continues its own slow transformation. The universe is not pausing while we travel. So if a mission sets out toward a target imagined by one civilization, what does it mean if the target that finally receives the travelers is no longer the same in any emotionally meaningful sense? Even on Earth, this happens in small ways. Someone leaves a hometown, returns decades later, and finds it changed beyond recognition. The streets remain, perhaps, but the shops are gone, the people are older, the mood has shifted, and the remembered place now exists mostly in the traveler's mind. That is within one lifetime, on one planet, across a modest span of time. Now stretch that principle across intergalactic scales. A ship begins its mission under one sky, with one image of the destination, one set of hopes, one set of meanings. Millions of years later, if arrival occurs at all, the destination may still exist physically, but the meaning attached to it may have dissolved entirely. It may no longer be the shore imagined at the beginning. It may simply be some place, reached by descendants, in a universe older than the one that launched them. Again, this does not make arrival false, but it does make completion less simple. Because what is being completed if both the traveler and the destination have changed so deeply that the original relationship between them has been erased? There is also the possibility that success itself would alter the meaning of the mission before the destination was ever reached. Suppose a generation ship became stable, healthy, and culturally rich enough to survive for a very long time. Suppose its people developed art, philosophy, governance, education, medicine, relationships, traditions, and a deep sense of belonging aboard the ship. Suppose life there became, not merely bearable, but real in the full human sense. At that point, the ship is no longer just a vehicle. It is a world. And if the ship becomes a world, then arrival becomes ambiguous. Why should a flourishing civilization abandon one functioning home for an uncertain new one simply because ancestors long ago pointed the ship toward a distant objective? The better the moving world works, the weaker the emotional necessity of the destination may become. This is one of the strangest paradoxes in the whole story. If the ship fails to become a home, the mission may collapse from suffering. If the ship succeeds too well as a home, the mission may dissolve into irrelevance. The people aboard might eventually decide that the journey has already, in some sense, found its own completion. Not in another galaxy, but in the creation of a viable world in motion. To outside observers, that may look like failure. The ship never reached the target. But from the inside, perhaps it would look different. Perhaps the destination ceased to be the point once life itself became meaningful on the way. And if that happens, then what exactly was completed? The journey to another galaxy, or the transformation of a ship into a civilization? These questions are not merely philosophical decoration. They belong to the practical reality of very long-duration missions. Human beings do not move through time unchanged. Meaning does not remain fixed simply because a plan was written down. There is another layer beneath this too, one that may be even quieter. A journey is not only a movement through space, it is also a movement through identity. When people imagine exploration, they often imagine adding something to themselves. Knowledge, experience, memory, perhaps wisdom, but they still imagine an underlying continuity. The explorer returns or arrives with a story that can be told from beginning to end. Intergalactic travel threatens that storytelling structure. The farther the journey stretches, the harder it becomes to keep one continuous narrative that a human mind can honestly inhabit. The voyage becomes archival rather than personal, recorded rather than remembered, passed down rather than lived whole. That matters because memory is one of the things that makes completion feel real. We know a trip is complete because we remember the leaving and the arriving as part of one arc. Remove that memory continuity, and the idea of completion becomes more institutional than human. The ship's log may say the mission is complete. The descendants may celebrate arrival. The archives may preserve the story. But the old human feeling of, we set out, and now we are here, becomes harder to locate. It is distributed across generations, shared by no one person in full. There is something almost tenderly sad about that. Not because such a mission would be meaningless. Far from it. It might be one of the most extraordinary achievements any civilization ever attempted. But achievement and completion are not always the same thing. Sometimes an act can succeed technically while remaining emotionally unresolved. And beyond all of this waits the universe itself, still widening. That may be the most severe point of all. Because even if a ship survives, even if a society endures, even if purpose remains coherent, even if navigation holds, the broader architecture of spacetime is still changing while the mission unfolds. The destination is not simply there in the same passive way a mountain is there for a hiker. It belongs to a cosmos in motion. For some nearby structures, like Andromeda, the story remains locally gentler because gravity binds our neighborhood together. But beyond that, the expansion deepens the difficulty. Some destinations recede not merely in the ordinary sense of motion, but because the space between structures continues to stretch. On the largest scales, the universe itself creates separation that no ordinary traveler can easily negotiate. And that means another kind of incompletion enters the story. Not the incompletion of failure, exactly. The incompletion of asymptote. The ship moves. The target remains ahead. The mission continues. But the deeper truth may be that certain horizons are not meant to be fully closed by motion alone. The traveler can approach, perhaps, yet the universe keeps revising the terms of what arrival would require. That is a very different kind of barrier from a wall or a locked door. It is not a sharp refusal. It is a drifting one. And drifting barriers can be more haunting than hard ones, because they allow hope to remain just alive enough to keep hurting. There is an old human instinct to believe that perseverance guarantees meaning. Keep walking, keep building, keep enduring, and sooner or later the world will reward the effort with completion. On Earth, that instinct has often served us well. But the universe beyond the galaxy may not always honor that structure. It may allow immense perseverance while withholding the neat emotional closure our species likes to attach to long effort. The mission may continue for ages and still end in something less clean than, "We made it." It may end in transformation, or divergence, or reinterpretation, or a destination so changed that arrival feels less like fulfillment and more like becoming somebody else in a place no ancestor truly knew. And there is one more possibility, perhaps the strangest of all. The journey might reveal that, beyond our galaxy, was never really a destination in the human sense to begin with. What do I mean by that? Only this. Human journeys usually have destinations that belong to the same scale of life as the traveler. A town, a mountain, a shore, a continent, even a planet, perhaps, if one day we master such movement more fully. These are destinations that can be imagined as places where life continues in recognizable form. The traveler remains the kind of being for whom the destination means something direct. But another galaxy may belong to a scale so much larger than the human rhythm of life that it resists being a destination in that old sense. It may be better understood as a direction of aspiration, an outer horizon of thought, a symbol of the universe's excess beyond our native world. Something real, yes, but real in a way that does not fit neatly into the emotional architecture of ordinary travel. That does not make the dream foolish. It makes it revealing. Because sometimes the point of a dream is not that it will be fulfilled in the form first imagined. Sometimes its value is that it teaches us what kind of beings we are, what kind of universe we inhabit, and where the edges of our assumptions begin to show. The dream of leaving the Milky Way may be one of those dreams. It teaches us that home is larger than we emotionally grasp. That emptiness can be as formidable as danger. That physics is not a mere inconvenience waiting to be outsmarted, but a profound structure that shapes possibility. That life is more planetary than we often admit. That long missions become cultural before they remain mechanical. That meaning itself is difficult to preserve across deep time. And that the universe is not still while we imagine crossing it. In that sense, perhaps the journey already gives something, even if completion remains forever in question. It gives perspective. And perspective, though quieter than conquest, may be the deeper gift. Because once you truly feel all of this, another thought begins to arrive, softer than the original dream and perhaps wiser. Maybe the value of looking outward is not only to leave, maybe it is also to understand where we already are. The Milky Way, which at first felt merely like the thing we hoped to escape, begins to look different under this light. Not like a cage. Not like some provincial starting point to be discarded the moment we grow ambitious enough. But like a vast and layered home, so immense that we have barely begun to know it. A place with hundreds of billions of stars, clouds of gas and dust, quiet dark matter, dead suns, new suns, ancient clusters, black holes, and more mystery than our species has yet had time to touch. Against the scale of all that, the urge to leap immediately to another galaxy begins to feel almost like a child standing in one great library and longing for the next before reading the first shelf. There is no shame in the longing. Longing is part of intelligence. But perhaps wisdom adds patience to longing. Perhaps it teaches us that wonder does not diminish when we accept limits honestly. In some ways it deepens. Because the universe is not required to be fully traversable in order to be beautiful. Not every shore must be reachable for the sea to matter. Not every light must be touchable for the night sky to be worthy of love. And not every impossible journey is useless simply because it remains incomplete. Sometimes incompletion itself is what reveals the scale of reality. That may be the quietest lesson in all of this. The journey beyond our galaxy might never be completed, not because effort is meaningless, but because the universe is larger, older, emptier, and more dynamically strange than the human idea of travel was built to handle. Completion, in the neat and ordinary sense, may belong to smaller worlds. Out here, on the largest scales, things may only ever be approximated, approached, inherited, reinterpreted, carried forward by beings who understand that to exist in the cosmos is not always to conquer distance, but to live honestly inside it. And perhaps that is enough for tonight. To lie still for a moment and feel the size of it. To feel that our galaxy is already vast beyond instinct, that the dark between galaxies is deeper than ordinary loneliness, that the laws of nature are neither cruel nor kind, only true, and that the dream of crossing the universe tells us as much about ourselves as it does about the stars. Maybe one day humanity will do astonishing things. Perhaps journeys that now seem impossible will become ordinary to minds and civilizations not yet born. It would be foolish to underestimate the future completely. But if we speak gently and honestly from where we stand now, the answer to the question feels quieter than triumph. Why might the journey beyond our galaxy never be completed? Because the distance is not just distance. It is time, energy, fragility, inheritance, drift, memory, expansion, and change. Because a ship may survive while its purpose transforms. Because a people may continue while the meaning of the destination grows uncertain. Because the universe itself keeps moving while the traveler tries to cross it. And because some horizons may teach their deepest truth not by being reached, but by showing us how far reality extends beyond the shape of our wishes. If you are still awake, and this slow thought carried you somewhere calm, feel free to subscribe, leave a like, or tell me in the comments what part stayed with you the most. And if you are already drifting off, then maybe that is fitting too. After all, some questions are not here to be solved before sleep. Only to be held for a little while beneath the quiet light of the stars.